Hello and welcome to Sleepy Science. What if your body is not a single fixed thing, but a living universe quietly rebuilding itself, listening to invisible signals, carrying ancient matter, hosting microscopic life, and remembering battles your conscious mind never saw? What if the skin you shed, the blood moving through your veins, the microbes living inside you, the electricity in your brain, the tiny signals controlling your muscles, and the cells repairing you in silence, are all part of one strange collaboration that makes being human far deeper than it feels from the outside? In this journey, we'll move gently through the hidden science of the human body. From cells that are replaced, bones that remodel, lungs filled with vast inner surfaces, and blood vessels stretching through impossible distances, to the liver's power to regrow, the stomach's powerful acid, the eye's direct connection to the brain, the quiet language of hormones, and the ancient bacterial ancestry still living inside your mitochondria. And as we begin, tell me in the comments where you're watching from and what the local time is there right now. These are not myths, exaggerations, or fantasy biology. They are real scientific truths that reveal the body as something more mysterious, more fragile, and more intelligent than a simple machine. So, if you're ready to drift beneath the surface of your own skin, subscribe and step into the quiet mystery with me. Because the deeper we look into the human body, the more it feels like you are not merely living inside yourself. You are being continuously created by countless hidden processes working together in the dark. Most cells in your body are not permanently yours. There is a quiet disappearing act happening inside you right now, so gentle and ordinary that you do not feel it, yet so complete that the body you call mine is never exactly the same body for very long. You wake up with the feeling of continuity, with the same name, the same memories, the same face in the mirror, the same hands reaching for the same cup, and because consciousness flows smoothly from one morning into the next. It is easy to imagine your body as a fixed object that simply ages over time, like a stone slowly weathered by rain. But your body is not a stone. It is closer to a living city at night, where buildings are repaired while people sleep, roads are resurfaced without ceremony, old structures are quietly removed, and new ones rise in their place before anyone notices the skyline has changed. Most of the cells that make up your body are not meant to stay forever. They are temporary workers in an astonishing biological system, appearing, serving, dividing, aging, dying, and being replaced, so the larger pattern of you can continue. This does not mean that every part of you is renewed at the same speed, and it does not mean the common myth that your entire body becomes completely new every 7 years is perfectly true. Reality is more interesting than that. Some cells are short-lived, some last for years, and some may stay with you for most of your life. Red blood cells, for example, circulate for roughly a few months before being cleared away and replaced. Cells lining parts of your digestive tract can turn over much faster because they face constant friction, acid, enzymes, and the passing movement of food. Many immune cells live only briefly, especially when they are called into action. Skin cells are continually pushed outward as newer cells rise beneath them. Meanwhile, some neurons in your brain, especially many in the cerebral cortex, may remain with you for decades, carrying traces of your life through long-lasting connections rather than constant replacement. The lens cells in your eyes are also unusually long-lived, holding a kind of biological memory of your earliest development. So the truth is not that you vanish and reappear all at once, but that you are a mosaic of different timelines. Some parts of you are renewed like waves washing over sand. Some are repaired slowly like old wood in a beloved house. Some remain like ancient stones in the foundation, and together they create the strange stability you experience as a single self. The reason this renewal happens is not mystical. It is practical, precise, and deeply necessary. Cells are living systems, and living systems wear down. Their membranes are stressed, their proteins become damaged, their DNA can be injured, their internal machinery can lose efficiency. A body that never replaced its vulnerable cells would not remain stable for long. So life developed a quiet strategy. Instead of preserving every tiny piece forever, it preserves the pattern. It keeps the larger organization alive by allowing small parts to leave. In some tissues, stem cells act like hidden reserves, producing new cells when old ones are lost. In others, mature cells divide when repair is needed. And in many places, damaged cells are removed through controlled processes that are not chaotic destruction, but careful biological editing. A cell can receive internal signals that it is no longer safe or useful, and rather than bursting open and harming its neighbors, it can dismantle itself in an orderly way, allowing its materials to be cleaned up and reused. There is something almost humbling in this. Your body survives not by refusing loss, but by making loss useful. It does not cling to every cell as if permanence were the same as life. It lets go, replaces, rebuilds, and continues. And yet, you still feel like you. That is the part that makes this science quietly philosophical. If many of the cells in your body are temporary, what exactly remains constant? Is it the material itself or the arrangement? Is you the exact collection of cells present today, or the ongoing process that keeps replacing them while preserving shape, memory, behavior, and awareness? Think of a river. You can stand beside it every morning and call it by the same name, even though the water moving through it is never the same water. Its identity is not in each individual drop, but in the pattern of flow, the banks that guide it, the direction it takes, the history it carries. Your body is similar. You are not a frozen object. You are a maintained pattern, a biological rhythm, a continuity made of change. The cells that held you together as a child are not all the same cells that hold you together now. Yet childhood did not disappear completely. It remains in the shape of your bones, the wiring of your nervous system, the immune lessons your body learned, the habits your muscles practiced, the emotional maps your brain built, and the memories that keep giving your past a place inside your present. You are not permanent in the way a statue is permanent. You are permanent in the way a flame is permanent while it keeps burning, always changing, always consuming, always renewing, and yet recognizably itself. This is why the body can feel so familiar and so mysterious at the same time. You touch your arm and assume it is simply your arm, but beneath that simple certainty is a living negotiation. Cells are being born from older cells. Others are reaching the end of their usefulness. Signals are being sent. Repairs are being made. Waste is being cleared. Tiny decisions are happening without your awareness. Not because your body is separate from you, but because most of what keeps you alive happens below the level of conscious thought. You do not need to command your blood to renew itself. You do not need to remind your tissues to repair small injuries. You do not need to supervise the replacement of worn-out cells. Life does this quietly, with an intelligence older than language. And perhaps that is the most beautiful part. The self you experience as stable is supported by constant surrender. To stay alive, your body must keep changing. To remain you, it must never remain exactly the same. So when you look in the mirror, you are not seeing a fixed thing slowly moving through time. You are seeing a process that has learned how to look like a person. You are seeing a temporary arrangement held together by memory, repair, renewal, and care. You are seeing a body that has already let go of countless microscopic versions of itself so that you could keep waking up inside the next one. And maybe this makes being human feel less like owning a body, and more like being entrusted with a living pattern, not a possession, not a machine, not a permanent object, but a soft, breathing continuity made from countless small endings. Every day, parts of you leave. Every day, parts of you begin. And somewhere between those departures and arrivals, you remain, not unchanged, but faithfully remade. Your gut can influence your mood. A strange conversation is happening beneath your ribs before you ever name what you feel. Long before a mood becomes a sentence in your mind, before you say, "I feel heavy today," or "I don't know why I'm anxious," your body may already be sending quiet messages upward from the deep, folded world of your gut. This does not mean your stomach secretly controls your personality, and it does not mean sadness can be explained by one organ alone. Human emotion is far too rich for that, shaped by memory, sleep, relationships, hormones, stress, genetics, sunlight, movement, and the stories you carry inside yourself. But the gut is not just a soft tube where food disappears. It is a living sensory landscape filled with nerves, immune signals, chemical messengers, and constant communication with the brain. You may think of mood as something that begins in your head, as if the brain sits alone in a silent control room, deciding how the day should feel. But the brain is not isolated. It listens to the body all the time. It listens to the heartbeat, the breath, the muscles, the immune system, and yes, the gut. That is why hunger can make the world feel sharper and colder. That is why nausea can make a room feel threatening. That is why butterflies in the stomach arrive before a speech, a confession, a first meeting, or a moment of fear. Your gut and brain are not strangers exchanging occasional messages. They are more like two musicians in the same slow song, adjusting to each other, sometimes gently, sometimes urgently, sometimes so subtly that you only notice the emotion and never hear the signal that helped create it. The main pathway often discussed is called the gut-brain axis, a two-way communication system connecting the digestive tract and the nervous system. One of its most important routes is the vagus nerve, a long wandering nerve that carries information between the brain and many organs, including the gut. Through this pathway, the brain can influence digestion when you are stressed, and the gut can send information back about fullness, discomfort, inflammation, and the internal state of the body. This is why emotional stress can affect digestion so quickly. A frightening thought can tighten the stomach. Chronic pressure can change appetite. Nervousness can speed things up or slow them down. The body does not draw a clean border between mental and physical the way language does. Inside you, feeling and function are braided together. The gut also communicates through the immune system. If the digestive tract becomes irritated or inflamed, immune signals can influence the brain's chemistry and behavior. Scientists have seen that inflammation in the body can be linked with fatigue, low motivation, and changes in mood. This does not mean every low mood comes from the gut, and it does not mean inflammation is the simple hidden answer to all emotional suffering. But it does show that mood is not only a cloud in the mind, it can also be a weather report from the body. When the body feels under threat, the brain may shift into a different mode. More cautious, more tired, more sensitive, less curious. In evolutionary terms, this makes sense. A sick or stressed body may benefit from slowing down, withdrawing, conserving energy, paying closer attention to danger. But in modern life, these ancient signals can become confusing. You may interpret a heavy mood as a personal failure, when part of it may be your body asking for rest, nourishment, safety, or recovery. Another layer comes from the chemicals involved in digestion and emotion. Many people hear that serotonin is made in the gut, and then imagine that the gut is directly producing happiness. The truth is more careful and more interesting. A large amount of the body's serotonin is found in the digestive system, where it helps regulate gut movement and other local functions. Most of that serotonin does not simply travel into the brain like a mood potion. The brain has its own serotonin systems, but the fact that the gut uses important chemical messengers shows how deeply biological your emotional life is. The same body that digests a meal is also involved in shaping energy, comfort, stress response, and the background tone through which experience is felt. The microbes living in the gut also appear to play a role, not as magical mood makers, but as part of a complex ecosystem that can produce substances, influence immune activity, and interact with digestion. Some gut bacteria can help produce short-chain fatty acids from fiber, and these compounds may support the gut lining and affect inflammation and metabolism. Researchers are still learning exactly how these microbial communities influence the brain, and the science is not a simple story where one food or one supplement transforms the mind. But the direction is clear enough to be fascinating. The emotional self is not floating above biology, it is rooted in it. What you eat, how you sleep, how much stress you carry, whether your body feels safe, and how your digestive system is functioning, can all become part of the emotional atmosphere you wake up inside. Even the relationship works both ways. Your gut can influence your mood, but your mood can influence your gut. Fear can change digestion. Grief can erase appetite. Long-term stress can alter gut movement and sensitivity. People with irritable bowel conditions often experience stronger links between gut discomfort and anxiety, not because the pain is imaginary, but because the communication lines between gut and brain can become more sensitive. The body begins to listen too loudly. Signals that should be background noise become alarms, and when alarms keep ringing, the mind begins to live differently. This is where the topic becomes more than biology. It becomes a new way to understand yourself. You are not weak because your emotions have bodily roots. You are not less real because mood can be shaped by nerves, signals, digestion, and chemistry. If anything, it makes emotion more real, not less. It means your sadness is not just in your head. Your anxiety is not only thoughts. Your calm is not merely an idea. Your inner life is embodied. It rises from the full orchestra of being alive. The quiet lesson is not that you can control your mood by controlling your gut perfectly. That would be too simple, and it would place too much blame on the person suffering. The better lesson is gentler. Your mind is listening to your body, so caring for the body is also a way of speaking to the mind. A balanced meal, enough fiber, steady sleep, hydration, movement, and moments of real rest are not small things. They are not separate from emotional life. They are part of the language your nervous system understands. Sometimes the path toward feeling better does not begin with forcing yourself to think differently. Sometimes it begins with asking what your body has been trying to say in a language older than words. And perhaps that is what makes the gut-brain connection so quietly humbling. You are not a mind trapped inside a machine. You are a living conversation. You are a brain shaped by a body shaped by its environment, an emotional life carried through nerves and blood and breath and digestion. Beneath every thought there is a pulse. Beneath every mood there may be signals moving in the dark. And when you begin to understand that, you may become less harsh with yourself. You may stop treating every feeling as a verdict on who you are, and begin to see some feelings as messages from a system trying, in its imperfect and ancient way, to keep you alive. Your body is home to trillions of microbes. You are not walking through the world as one creature, but as a quiet ecosystem wearing a human shape. Every step you take, every breath you draw, every surface you touch carries you through an invisible exchange of life so small that your eyes cannot see it, yet so intimate that it has been with you since your earliest days. Your body is home to trillions of microbes, bacteria, fungi, viruses, and other microscopic organisms living across your skin, inside your mouth, along your airways, in the folds of your body, and most densely in your digestive tract. They are not all enemies. In fact, many are ordinary companions, ancient residents of the human body, living in layered communities that scientists call the microbiome. For a long time, people were taught to imagine microbes mainly as threats, as things to destroy, scrub away, sterilize, and fear. And some microbes truly can be dangerous. Certain bacteria, viruses, and fungi can invade tissues, trigger disease, and overwhelm the body's defenses. But the deeper truth is more complex and more surprising. Life inside you is not a clean, empty room protected from the outside world. It is more like a crowded rainforest, where balance matters more than silence. A healthy body is not microbe-free. It is carefully inhabited. On your skin, microbes help occupy space that more harmful organisms might otherwise take. In your mouth, they form complex communities that can support health when balanced, but contribute to tooth decay or gum disease when conditions shift. In your gut, they help break down parts of food that your own enzymes cannot fully digest, especially certain fibers from plants. When they ferment these fibers, they can produce helpful substances that nourish cells in the colon and influence the local environment. Some microbes help make or modify vitamins. Others interact with bile acids, support digestion, and help train the immune system to distinguish between ordinary companions and real threats. This training is one of the most fascinating parts. Your immune system does not grow up in isolation. It learns in conversation with the microbial world. From early life onward, Your body is exposed to microbes from birth, feeding, touch, food, soil, pets, other people, and the spaces you live in. These encounters help shape how the immune system responds. Too weak a response and harmful invaders may spread. Too aggressive a response, and the body may begin to overreact to harmless things. The microbiome is part of that education, not as a single teacher with one lesson, but as a whole classroom of signals, pressures, and patterns. And what makes this even more extraordinary is that your microbiome is personal. It is not identical to anyone else's. It is shaped by how you were born, what you eat, where you live, which medicines you have taken, especially antibiotics, what animals you have been around, what environments you enter, how you age, and even how your daily habits change over time. Two people can share a home, a meal, even a life, and still carry different microbial landscapes within them. You are not only genetically human, you are ecologically unique. But this is where the truth needs care. It would be easy to turn the microbiome into a magical explanation for everything: mood, weight, energy, disease, personality, destiny. The science is powerful, but it is not that simple. Researchers have found links between microbial patterns and many aspects of health, but a link does not always mean a direct cause. A certain microbial change may contribute to a condition, or it may result from it, or both may be shaped by something else, like diet, medication, inflammation, or lifestyle. This is why simple claims like "take this one probiotic and fix your whole body" are usually too neat for reality. The microbiome is not a button. It is an ecosystem. You do not heal a forest by planting one tree and ignoring the soil, the weather, the water, and the surrounding life. In the same way, supporting your microbial world is usually less about one miracle product and more about steady conditions. Diverse plant foods, enough fiber if your body tolerates it, fermented foods for some people, careful use of antibiotics when truly needed, sleep, movement, and a life that gives the body a chance to regulate itself. Antibiotics can be life-saving, and they are one of the greatest tools in medicine, but they can also disturb microbial communities because they may affect helpful bacteria along with harmful ones. Sometimes those communities recover. Sometimes they shift for longer. This does not mean antibiotics should be feared when necessary. It means they should be respected. The same is true of hygiene. Cleanliness matters. Washing hands can prevent disease. Safe food practices matter. But trying to live as if all microbes are enemies misunderstands what the human body is. You are not separate from the microbial world. You are a meeting place for it. You are a shoreline where human cells and microbial lives touch, negotiate, compete, cooperate, and change together. And perhaps the most humbling part is that some of the life inside you is not merely passing through. It participates in the conditions that make your body livable. It helps maintain barriers. It interacts with immune cells. It transforms food into signals. It occupies space. It adds chemical variety to the inner world you carry. You are still human, of course. You are not controlled by microbes, and you are not less yourself because you host them. But being human has never meant being alone. It has always meant being a collaboration. A body built from human tissue and surrounded by invisible partners. Some helpful, some harmless, some dangerous, if balance breaks. So the next time you think of yourself as a single, isolated being, pause for a moment. Your skin is not an empty surface. Your mouth is not a sterile doorway. Your gut is not just a tube of digestion. You are carrying a hidden population, a living shadow community, an unseen ecology that has shaped human survival for longer than memory can reach. And maybe this changes the way you imagine your own body. Not as a sealed container, not as a pure individual separated from the world, but as a breathing habitat, a moving planet of cells and signals, where life makes room for other life, and where the word you becomes wider, stranger, and more alive than it first seemed. Your brain runs on electricity and chemistry. Before a thought becomes a thought, it begins as a tiny storm moving through living tissue. Somewhere inside your skull, in the soft folded darkness of the brain, Billions of nerve cells are constantly shifting between silence and signal, waiting and firing, receiving and releasing, turning invisible physical events into the experience you call me. You may feel your mind as something weightless, almost untouchable, like a private sky where memories drift, words appear, fears gather, and dreams open without warning. But the mind does not float above the body like a ghost. It depends on matter doing very specific things. Your brain runs on electricity and chemistry, not like a simple machine with wires and switches, but like a living storm system where sparks and substances work together so quickly, so delicately, that the result feels seamless. Every time you recognize a face, move your fingers, hear your name, remember a childhood room, feel embarrassment, solve a problem, or imagine tomorrow, your brain is using electrical impulses to move information along neurons and chemical messengers to pass that information from one cell to the next. This is not the cold electricity that powers a lamp. It is biological electricity created by tiny charged particles moving in and out of nerve cells through microscopic gates in their membranes. A neuron at rest is not dead or empty. It is like a held breath, maintaining a careful difference between the inside and outside of the cell. When the right signal arrives, that balance shifts, gates open, charged particles move, and a brief electrical wave travels down the neuron. This wave is called an action potential, but you can imagine it more gently as a traveling whisper that becomes loud enough to cross the length of a cell. It does not carry a picture or a word by itself. It is more like a pulse in a code, a timing mark, a small yes traveling through the living network. But when that pulse reaches the end of the neuron, electricity alone is not enough. The signal arrives at a tiny gap called a synapse, where one cell does not quite touch the next. And here, the brain changes language. The electrical message triggers the release of chemical messengers called neurotransmitters. These molecules cross the gap and bind to receptors on the next cell, like keys meeting locks, shaping whether that next neuron becomes more likely to fire, less likely to fire, or quietly adjust its state. In this way, your brain is bilingual. It speaks electricity inside neurons and chemistry between them. The two languages are inseparable. Electricity gives speed. Chemistry gives nuance. Electricity can flash through a pathway with remarkable timing. Chemistry can strengthen, soften, pause, amplify, filter, or reshape the meaning of the signal. And from that partnership comes everything you experience as inner life. Dopamine, for example, is often oversimplified as the pleasure chemical, but it is more accurately involved in motivation, reward learning, expectation, and the pull towards something that seems important. Serotonin is not simply happiness in liquid form. It plays roles in mood, appetite, sleep, and many body systems. Glutamate is one of the brain's major excitatory messengers, helping neurons activate one another. GABA often acts as a calming or inhibitory messenger, helping prevent the brain from becoming uncontrolled noise. Acetylcholine is important for attention, learning, and muscle activation. None of these chemicals create a feeling alone, like pressing one button for joy or one button for fear. The brain is not that simple. A mood, a memory, or a decision emerges from patterns. Which cells fire? When they fire, which circuits are active? Which signals are strengthened? Which are quieted? And what the body and environment are doing at the same time. This is why the brain can be both physical and mysterious without contradiction. Knowing that thought depends on electricity and chemistry does not make love less real, grief less deep, or wonder less sacred. It simply means that your most intimate experiences have a physical form. A memory is not stored like a video in one tiny drawer. It is held across networks, in changed connections, in pathways that have become easier to activate because life has carved them through repetition and emotion. Learning is not only understanding in an abstract sense, it is the brain physically changing, adjusting synapses, strengthening some roots, weakening others, building a new readiness to respond. When you practice a skill, you are not merely trying harder. You are helping your nervous system become more efficient at a pattern. When you repeat a fear, a habit, or a comforting ritual, you are also training circuits, teaching the brain what to expect and what to prepare for. This is one reason the brain is so powerful and so vulnerable. It can adapt, but it can also become trapped in loops. It can protect you, but sometimes it protects you from dangers that are no longer present. It can predict the world, but sometimes its predictions become heavier than the world itself. And beneath all of that, the electrical and chemical dance continues. Even at rest, your brain is not truly resting. It is monitoring, regulating, remembering, imagining, adjusting the body, sorting signals, and preparing for what might come next. The quiet moment when you stare at a ceiling and think nothing is happening is still full of activity. Networks are humming beneath awareness. Some parts of the brain are coordinating breathing and heartbeat. Others are maintaining posture, filtering sound, updating your sense of where your body is in space, and letting thoughts rise and fade. The miracle is not that your brain works like a computer. It is that it does not. A computer follows design circuits made of metal and code. Your brain is wet, alive, changeable, shaped by sleep, food, stress, touch, language, injury, memory, and time. Its electricity is born from cells. Its chemistry is shaped by life. Its signals are not just data. They are part of a body trying to survive, understand, connect, and make meaning. So when you say, "I had an idea," what you are really describing is matter briefly organizing itself into insight. When you say, "I remember," you are describing a pattern reawakening. When you say, "I feel," you are naming a wave of body and brain activity that has become personal. This can feel unsettling because it places the self inside biology rather than above it. But it can also feel strangely beautiful. You are not less than your chemistry. You are chemistry that learned to wonder about itself. You are not merely electricity. You are electricity arranged into memory, attention, imagination, and care. Inside your skull, tiny living signals rise and fall, and somehow their rhythm becomes the sound of your own inner voice. Every thought is a spark, but not only a spark. Every feeling is chemistry, but not only chemistry. The physical world has found a way to become experience. And for a little while, through you, the universe does not just exist. It notices. Your heart can beat outside the body for a while. A heart does not wait for the rest of the body to tell it that it is alive. That may be one of the strangest and most quietly unsettling truths about the organ you feel only as a rhythm beneath your ribs. You grow up imagining the heart as something deeply dependent, a loyal pump hidden in the chest, obeying the brain, responding to emotion, racing when you are afraid, slowing when you sleep, aching when grief moves through you. And all of that is partly true. The heart is shaped by the nervous system, hormones, oxygen, temperature, and the needs of the body around it. But at its core, the heart carries its own rhythm-making ability. It is not like a simple muscle that waits silently until a command arrives. Inside the heart are specialized cells that can generate their own electrical impulses, especially in a small region called the sinoatrial node, often described as the heart's natural pacemaker. These cells do something remarkable. They slowly build toward a signal again and again, creating waves of activity that spread through the heart muscle and make it contract in a coordinated way. This is why, under the right conditions, a heart can continue beating for a while, even after it has been removed from the body. Not forever, not magically, not as a symbol in a horror story, but as a real biological fact. If the heart still has enough oxygen, the right salts and nutrients, and the proper conditions around its cells, it can keep producing rhythm because the machinery for rhythm is built into the heart itself. In laboratories and operating rooms, this truth becomes visible in ways that can feel almost impossible to watch. During heart transplantation, a donor heart is carefully removed, preserved, transported, and placed into another person's chest. Traditionally, donor hearts were cooled to slow their metabolism, giving surgeons a limited window before the tissue suffered too much damage. More recently, some systems can keep a donor heart warm and supplied with oxygen-rich fluid outside the body, allowing it to beat while it is being transported or evaluated. This does not mean the heart is independent in the full sense. It is not a separate creature. It cannot think, feel, choose, or survive indefinitely on its own. But it shows that the heart is more autonomous than many people imagine. Its rhythm is not merely imposed from above. It arises from within. Even small pieces of heart tissue, if kept alive in controlled conditions, can sometimes contract because cardiac muscle cells are designed for rhythmic activity. They are built to communicate with their neighbors, passing signals cell to cell, so that individual contractions become a unified beat. In your body, this coordination matters more than raw strength. A heart is not useful if every part squeezes randomly. It must behave like a synchronized wave, first filling, then contracting, then resetting, thousands of times a day, without you consciously asking it to continue. The brain and nerves can speed this rhythm up or slow it down. Stress can push it faster. Rest can let it ease. Chemical signals in the blood can influence its pace and force. But the basic beat, the repeating spark of contraction, comes from the heart's own pacemaking system. This is why a person can be declared brain dead, while the heart may still beat for a time with medical support, as long as oxygenated blood is being circulated and the body's internal conditions are maintained. It is also why cardiac arrest is so urgent. When the heart's rhythm becomes chaotic or stops effectively pumping blood, the brain and other organs lose oxygen quickly. The heart may have its own rhythm, but the body depends on that rhythm becoming circulation. A beat that does not move blood properly is not enough. This is the difference between movement and life support, between a muscle twitching and an organism surviving. And that distinction is important because the sight or idea of a heart beating outside the body can easily become misunderstood. It is not proof that the heart contains the soul. It is not evidence that emotion lives only in the chest. It is biology doing what biology evolved to do, maintaining motion through specialized cells, chemical balance, oxygen use, and careful structure. Yet the fact becomes no less beautiful when explained. In some ways it becomes more beautiful. Your heart is not just a symbol of love drawn on paper. It is a tireless muscular organ that begins beating early in development and continues through nearly every moment of your life. It contracts because calcium moves inside cells, because proteins slide past one another, because signals pass through tissue with astonishing timing, because valves open and close so blood moves in one direction, because pressure rises and falls in chambers you never see. Each beat is a small event of engineering and vulnerability. It must be strong enough to push blood through the body, but delicate enough to adapt from sleep to fear, from sitting quietly to running, from childhood to old age. And when removed from the body under the right conditions, it can continue for a while because its rhythm is not borrowed moment by moment from your conscious mind. It is written into the tissue. There is something humbling about that. The organ, so often treated as the center of feeling, is also a disciplined piece of living physics, a chambered pump with its own timing, its own internal logic, its own stubborn insistence on continuing. You do not command it, yet you live by it. You do not hear every signal inside it, yet every part of you depends on the result. And maybe this is why the heart feels so powerful in human imagination. Not because it is mysterious in the absence of explanation, but because explanation reveals how much quiet work is happening beneath every ordinary second. Somewhere inside you, without applause, without rest, a rhythm repeats. It is shaped by the body, but not fully ruled by it. It belongs to you, yet it can briefly continue apart from you. It is intimate, automatic, fragile, and relentless. And when you understand that your heart can beat outside the body for a while, the lesson is not that the heart is separate from life, but that life is made of systems so deeply prepared to continue that even when removed from their usual home, they still try for a little while to keep the rhythm going. Your bones are alive and constantly changing. Beneath your skin, your skeleton is listening. It may seem silent, hidden and finished, like a white framework built once in childhood, and then simply carried through life. But your bones are not dead beams holding up a body. They are living organs, fed by blood, filled with cells, wired with sensation, shaped by movement, and constantly remodeled in response to the way you live. When you imagine bone, you may picture something dry, hard, and museum-like, the kind of thing left behind after life has gone. But the bones inside you are nothing like that. They are active tissue. They breathe in the language of biology. They repair, adapt, store minerals, protect soft organs, help make blood cells, and quietly change their inner architecture as your body's needs shift. Every step you take becomes information. Every time you lift weight, climb stairs, sit too long, heal from injury, or move through gravity, your skeleton receives signals about what kind of world it must prepare for. It is not just a structure, it is a record of use. Deep inside bone, specialized cells are working in a slow and careful rhythm. Some cells, called osteoclasts, break down old or weakened bone tissue. Others, called osteoblasts, build new bone in its place. This process is called remodeling, and it happens throughout life. It is not random destruction. It is maintenance. It is your skeleton's way of removing tiny damage before it becomes dangerous, adjusting strength where force is needed, and keeping the balance of minerals in the blood. Bone is partly made of a strong mineral structure that gives it hardness, but it also contains collagen, a flexible protein that helps it resist breaking. This combination is important. If bone were only hard, it would be brittle. If it were only flexible, it would not support you. Its strength comes from the marriage of firmness and give, like a tree branch that can resist pressure because it is not pure stone. Inside the bone are living cells called osteocytes, buried within the mineral matrix like quiet guardians sealed inside the walls they helped create. These cells sense mechanical strain. They can detect when a bone is being stressed, when pressure changes, when the skeleton needs reinforcement, and when it may be losing purpose because it is not being used enough. This is why movement matters so deeply. Your bones are shaped by load. When you use them, they receive the message that strength is needed. When they are unused for long periods, as in extended bed rest or spaceflight, the body may begin to reduce bone density because maintaining strong bone is metabolically costly. The skeleton adapts to the world it believes you are living in. In that sense, your bones are not only holding your past, they are predicting your future. They are asking, will this body need strength here? Will this person keep standing, carrying, walking, resisting gravity? And your habits answer. Bone also plays a hidden role in blood. Inside certain bones is marrow, the soft inner tissue where many blood cells are produced. Red blood cells, white blood cells, and platelets begin their lives there through a process that is constantly renewed. This means your skeleton is not merely a cage around life. It is one of the places where life is manufactured. The same ribs that protect your lungs, the same pelvis that carries your weight, the same spine that holds you upright also contain inner spaces where the body prepares oxygen carriers, immune defenders, and clotting helpers. Your bones are both architecture and nursery. They are walls and workshops. They are strength with a pulse hidden inside. And because bones store important minerals like calcium and phosphorus, they also participate in the chemistry of the whole body. Calcium is not only for bones, it is essential for muscle contraction, nerve signaling, and many other functions. So the body must carefully regulate how much calcium stays in the blood and how much is stored in bone. Hormones help manage this balance, which means your skeleton is part of a larger conversation involving the kidneys, intestines, glands, diet, sunlight, and movement. Again, the skeleton is not separate. It is woven into the whole body's economy. When bones break, their living nature becomes even clearer. A fracture is not repaired like a cracked cup glued from the outside. The body launches a biological construction project. Blood forms around the injury. Inflammatory signals arrive. New tissue begins to bridge the break. Cartilage-like material may form first, then gradually harden into new bone. Over time, the repair is remodeled, reshaped, and strengthened. The healed area may look rough at first, then become more organized as the body continues to work. This healing is not perfect in every case, and it depends on blood supply, alignment, nutrition, age, health, and care. But the basic ability is astonishing. Bone is one of the few tissues that can often heal by making more bone, not just scar. It tries to restore structure, not merely patch damage. And yet bones also tell the story of time. In youth, building often outpaces breakdown as the skeleton grows stronger. Later, maintenance becomes the main task. With aging, hormonal changes, reduced activity, illness, or poor nutrition, bone loss can become greater than bone formation, making bones more fragile. This is why osteoporosis can be so dangerous. Bones may look normal from the outside, while quietly losing density within, becoming more likely to fracture from falls or even small stresses. But this does not make the skeleton a symbol of inevitable decline. It makes it a reminder that strength is a relationship. Bones respond to what they are given: motion, nourishment, sunlight. For vitamin D production, resistance, rest, and medical support when needed. They are not fixed destiny. They are living tissue in negotiation with life. Perhaps that is the deepest lesson hidden inside your skeleton. The hardest part of you is not rigid in the way you think. It changes, it listens, it rebuilds itself in silence. The bones that seem to represent permanence are actually proof that permanence is maintained through renewal. They carry you not because they never change, but because they never stop changing carefully enough to keep you standing. So the next time you rise from a chair, place your feet on the floor and feel your weight move through your legs. Remember that your skeleton is not just a frame beneath you. It is a living archive of pressure, healing, adaptation, and time. It has been shaped by every step, every strain, every childhood fall, every long walk, every season of growth. And in its quiet mineral language, it keeps asking the same ancient question: what kind of life must I become strong enough to hold? Your immune system remembers invisible wars. Inside you, there is a war archive written without ink, stored not in books or memory as you know it, but in living cells that remember enemies you never saw. You may think of memory as something belonging to the mind, a face from childhood, a room you once slept in, a voice that still returns when the world grows quiet. But your immune system has its own kind of memory, older than language and colder than nostalgia, a biological record of past invasions, close calls, and microscopic battles fought in the dark corridors of your body. Most of these wars passed without ceremony. You did not watch a virus enter through your nose, or a bacterium slip through a tiny wound, or a fungal spore land on your skin. You did not see immune cells rushing toward chemical alarms, surrounding threats, releasing signals, destroying infected cells, cleaning debris, and deciding what must be remembered. Yet your body noticed. It always notices. Every fever, every swollen gland, every day when you felt strangely tired, every cut that reddened before healing, every childhood infection you barely recall may have left behind more than a story. It may have left behind trained defenders. The immune system is not a single thing, not one invisible shield floating around you. It is a vast layered defense network made of cells, organs, proteins, barriers, and signals. Your skin is part of it, acting as a wall. The mucus in your airways is part of it, trapping particles before they move deeper. Your stomach acid, tears, saliva, lymph nodes, spleen, bone marrow, white blood cells, antibodies, and chemical messengers all belong to this restless system of protection. Some parts respond quickly and broadly, like guards rushing towards smoke before knowing exactly what is burning. This is often called the innate immune response. It does not need long study before acting. It recognizes general signs of danger, moves fast, creates inflammation, and tries to contain the threat. But another part of your immune system is more specific, more patient, and more astonishing. This adaptive system learns. It can recognize particular features of a pathogen, called antigens, and build a targeted response against them. Certain immune cells, especially B cells and T cells, are central to this process. B cells can produce antibodies, which are proteins shaped to bind to specific targets, helping block invaders or mark them for destruction. T cells can help coordinate immune responses or kill infected cells directly. At first exposure, this response may take time, because the body has to identify the enemy, activate the right cells, multiply them, and refine the attack. But once the battle ends, the immune system does not simply erase the event. Some of those cells remain as memory cells. They are like quiet veterans stationed in the body, carrying the shape of an enemy in their biological awareness. If the same threat appears again, the response can be faster, stronger, and more precise. This is why some infections are usually worse the first time and milder or prevented the next time. It is also the principle behind vaccination. A vaccine does not need to give you the full danger of a disease to teach your immune system. It presents a safe version, a piece, an instruction, or a weakened or inactive form, depending on the vaccine type. So the immune system can practice recognition and build memory without facing the full force of the real infection. That memory may later help your body respond before the pathogen spreads widely. This is not magic. It is training. It is rehearsal for a war you may never have to fully fight. And when you understand this, immunity becomes more than a medical word. It becomes a story of preparation, recognition, and survival. But immune memory is not perfect, and this is where the science becomes more honest. Some pathogens change their appearance over time, like influenza viruses, making it harder for old immune memory to fully recognize new versions. Some infections do not produce lifelong protection. Some immune responses fade and need reminders, which is why booster doses exist for certain vaccines. And sometimes the immune system remembers the wrong things too strongly. Allergies happen when the immune system reacts to harmless substances as if they are dangerous. Autoimmune diseases happen when parts of the immune system mistakenly attack the body's own tissues. So this powerful memory must be balanced by tolerance, the ability to know not only what to fight, but what to leave alone. That may be one of the deepest lessons hidden in immunity. Survival depends not only on defense, but on discernment. A body that fights everything cannot live peacefully inside itself. It must learn the difference between enemy and self, between danger and ordinary life, between invasion and coexistence. And this learning begins early, shaped by genetics, infections, vaccines, environment, the microbes that live with you, and the everyday exposures that teach the immune system what kind of world it inhabits. Your lymph nodes, those small structures that can swell when you are sick, are like meeting halls where immune cells gather, share information, and organize responses. Your bone marrow produces many of the cells that patrol your blood. Your spleen helps filter blood and supports immune activity. There is an entire geography of defense inside you, a hidden nation of watchers, messengers, scouts, soldiers, and peacekeepers. And most of the time, when everything goes well, you never know they are working. That is the strange mercy of immunity. Its success often feels like nothing happened. A pathogen is stopped before it becomes a crisis. A damaged cell is cleared before it becomes a problem. A small infection is contained before it enters your awareness. You experience ordinary health, while beneath it, countless decisions have already been made on your behalf. This does not mean you are invincible. The immune system can be overwhelmed, weakened, confused, or harmed. It needs sleep, nutrition, recovery, and the larger support of the body. It is not a superhero separate from your life. It is part of your life, shaped by your body's condition and the world around you. But it is still extraordinary to realize that you are carrying memories of battles you never consciously witnessed. Your body has survived storms your mind never named. It has learned from invisible enemies. It has archived danger in cells that may wait silently for years. And perhaps this changes the way you think about strength. Strength is not always loud. Sometimes it is a memory cell resting quietly in tissue. Sometimes it is an antibody ready to bind. Sometimes it is a fever that feels miserable, but reflects a system trying to make the body less comfortable for an invader. Sometimes it is inflammation arriving as a controlled fire, dangerous if it spreads too far, but useful when kept in its proper place. Your immune system is not merely protecting you from the outside world. It is constantly negotiating your relationship with that world, deciding what may enter, what must be challenged, what can be tolerated, and what must never be forgotten. So when you look back at your life, remember that your story is not only held in photographs, scars, and memories. It is also held in the quiet intelligence of your cells. You are a person made partly of remembered survival. Beneath your calmest days, there are records of invisible wars. And inside that hidden archive, your body keeps whispering the same ancient promise. I have seen danger before, and I am still learning how to keep you here. Your skin is an organ. You shed every day. Every day, you leave a faint, invisible trail of yourself behind, not as a metaphor, but as biology quietly falling away. You do not notice it happening because it is too soft, too ordinary, too constant, but as you move through rooms, touch fabric, sleep in your bed, pull on a shirt, scratch your arm, or simply sit still, tiny dead cells from the outermost layer of your skin are being released into the world. They drift into dust, settle on surfaces, mix with the air of your home, and become part of the unseen evidence that you were there. It sounds almost unsettling at first, as if the body is slowly losing itself grain by grain. But this shedding is not a sign of failure. It is one of the reasons you are protected. Your skin is not just a covering stretched over the body like cloth over a frame. It is an organ, the largest organ you have, alive with blood vessels, nerves, glands, immune activity, pigment cells, repair systems, and layers of tissue that do far more than hold you together. It is your border with the world, the place where inside becomes outside, the living wall that feels warmth, pressure, pain, wind, sunlight, softness, injury, and the nearness of another person. And because it stands at the edge of everything, it must renew itself constantly. The outer layer of the skin, especially the stratum corneum, is made of flattened cells that are no longer alive in the usual sense. They have completed their journey upward from deeper layers, filled with tough protective proteins, lost their nuclei, and become part of a flexible shield. These cells are like the final bricks in a wall, not useless because they are dead, but useful because they form a barrier. They help keep water inside you, help block many harmful substances from entering, and provide a surface that can endure friction, dryness, contact, and the small assaults of daily life. Eventually, those outer cells loosen and fall away, while newer cells rise beneath them to replace what is lost. This process is called desquamation, and it is happening all the time, quietly maintaining the surface you rarely think about. Your skin is therefore not a static wrapper. It is a moving landscape, renewing from below and shedding from above. A slow conveyor of protection that keeps the boundary fresh. But skin is not only a wall, it is also a sensor. Embedded in it are nerve endings and specialized receptors that help you detect pressure, vibration, temperature, and pain. When you place your hand on a warm cup, your skin does not merely touch heat. It translates a physical condition into a signal your nervous system can understand. When something sharp threatens to cut you, pain receptors can warn you before the damage grows worse. When a breeze moves across your arm, tiny hairs and sensitive receptors help create that delicate awareness of air. This means the skin is not passive. It is constantly reporting, constantly listening, constantly turning the outside world into information. It is also part of temperature regulation. When you are hot, blood vessels in the skin can widen, bringing more warm blood near the surface so heat can escape, and sweat glands release fluid that cools you as it evaporates. When you are cold, blood vessels can narrow to conserve heat, and tiny muscles attached to hairs can create goosebumps, a reflex that mattered more to hairier ancestors than it does to modern humans. Even that small shiver across your skin is a trace of evolutionary history, a reminder that your body still carries old solutions from lives lived long before yours. Your skin also helps protect you from sunlight while depending on sunlight in careful measure. Cells called melanocytes produce melanin, the pigment that helps absorb ultraviolet radiation and gives skin much of its color. More melanin can provide more natural protection against sun damage, though no skin is immune to harm from excessive ultraviolet exposure. At the same time, sunlight on the skin helps the body produce vitamin D, which supports bone health and other functions. So the relationship between skin and sun is a balance, not a simple command to avoid or seek it blindly. Your skin is negotiating with light, taking from it what life can use while defending against what can injure. And beneath this visible surface is a world of repair. When you get a small cut, the skin responds with remarkable speed. Blood vessels constrict and clotting begins. Inflammatory signals bring immune cells to help clean the area and reduce the risk of infection. New tissue forms. Cells migrate across the wound. Collagen is laid down to strengthen the repair. Over time, the scar may fade, though it often remains as a trace of what happened. A scar is not just damage. It is a record of survival, a place where the body closed a doorway before the outside world could move too far in. Skin also carries personal history in other ways. Freckles from sunlight, stretch marks from growth or change, calluses from repeated pressure, wrinkles from time, expression, and the gradual alteration of collagen and elasticity. These marks are often treated as flaws, but biologically, they are evidence of contact between a living body and a changing life. A callus is the skin learning pressure. A wrinkle is not only aging, it is movement repeated into texture. A scar is a sentence written by repair. Even the dust your skin contributes to the world is a reminder that identity is not sealed. You are constantly exchanging matter with your surroundings. You breathe in, breathe out, shed, absorb, touch, respond. And yet, skin also gives you the powerful feeling of being a separate self. It draws the line where you seem to end. It lets you feel the difference between your hand and the table, your body and the air, your face and the rain. But that line is more alive and negotiable than it appears. Your skin is not a border made of stone. It is a border made of living decisions, opening and closing pores, healing small wounds, sensing danger, cooling heat, holding moisture, resisting invasion, and shedding what no longer serves. The deepest truth is that your skin protects you by letting go. It does not try to preserve every outer cell forever. It releases the old surface so a newer one can take its place. In that way, the skin teaches a quiet lesson the mind often resists. Renewal requires loss. To remain whole, something must be shed. To keep the boundary strong, the surface must change. So the next time you look at your hand, your face, or the fine lines on your body, remember that you are not seeing a simple covering. You are seeing a living organ at the edge of the world, a sensitive shield that has touched every object you have ever held, felt every season you have walked through, protected you from more threats than you will ever know, and left behind countless invisible pieces of itself so you could keep moving forward. Your skin is where life meets everything else, and every day in silence it gives a little of itself away to keep you here. Your blood carries ancient elements made in stars. The red in your blood is carrying a memory older than Earth. Long before your first breath, before your body had a name, before any human heart ever pushed blood through warm tissue, some of the elements now moving inside you were forged in places so violent and bright that ordinary imagination almost breaks against them. When you look at blood, you may think of injury, life, fear, warmth, or the quiet rhythm of survival. But hidden inside that red river is a cosmic history. Your blood is not only biological, it is astronomical. It carries iron, and that iron did not begin inside your body, inside your parents, inside the soil, or even inside this planet. The early universe, shortly after the Big Bang, mostly made the simplest elements, especially hydrogen and helium, with small traces of a few others. It did not simply produce the rich periodic table needed for bones, blood, oceans, rocks, nerves, and breath. The heavier elements had to be made later, inside stars, and in the powerful events connected to their lives and deaths. Stars are not just lights in the sky. They are furnaces of transformation. Deep in their cores, under immense pressure and heat, atoms are pressed together and changed into heavier atoms, releasing energy that can shine across space for millions or billions of years. A star spends much of its life turning lighter elements into heavier ones, step by step, building complexity in the dark. But iron is special. For many large stars, iron marks a kind of limit. When a massive star builds up an iron-rich core, it can no longer gain useful energy by fusing iron the way it did with lighter elements. The balance that held the star up begins to fail. Gravity pulls inward. The core collapses. The outer layers can explode outward in a supernova, scattering newly formed elements into space. Other kinds of stellar explosions, including those involving white dwarf stars, also help produce and spread iron. So the iron in your blood is not simply from a star, in a soft, poetic sense. It is connected to real astrophysical processes, to stellar interiors and explosions, to ancient matter thrown across space before the sun was born. The atoms that now help your blood carry oxygen were once part of a cosmic recycling story, drifting through interstellar clouds, joining the material that formed our solar system, becoming part of Earth, entering rocks, oceans, soils, plants, animals, and eventually the food chains that helped build you. Inside your body, iron has a very specific job. It sits at the center of hemoglobin, the protein in red blood cells that binds oxygen in the lungs and releases it to tissues that need it. This is one reason blood is red. When oxygen binds to hemoglobin, it changes the way the molecule absorbs and reflects light, giving oxygen-rich blood its brighter red color, while blood returning from tissues appears darker red. It is not blue inside your veins, despite the common myth. It is always some shade of red, changed by oxygen levels, depth under the skin, and the way light passes through tissue. Each red blood cell is packed with hemoglobin, and each hemoglobin molecule contains iron atoms positioned in a way that allows oxygen to attach and detach without being permanently trapped. That balance is vital. If oxygen held too weakly, it would not be carried well. If it held too tightly, it would not be released where your cells need it. Every breath you take depends on this quiet precision. Air enters your lungs. Oxygen crosses into the blood. Hemoglobin catches it. The heart sends it outward. Your tissues receive it so they can release energy from food and continue their work. You may experience this as simply being alive, but underneath that ordinary feeling is a chain of events connecting your lungs to your blood to your cells to ancient chemistry, and that chemistry to stars that died before Earth existed. There is something deeply humbling in realizing that your body did not invent its materials. It inherited them. The calcium in your bones, the carbon in your cells, the oxygen in your breath, the iron in your blood, all of it belongs to a universe that was building long before you arrived. You are not separate from cosmic history. You are one of its temporary arrangements, and blood makes this truth intimate because it moves. It is not locked in stone or hidden in distant space. It pulses through you right now. A piece of ancient stellar matter is not sitting silently in a museum. It is helping you climb stairs, close your eyes, think, heal, speak, dream, and listen. When you feel your pulse at your wrist, you are touching a rhythm that depends partly on atoms born from enormous events far beyond any human lifetime. But this fact should not be twisted into fantasy. It does not mean your blood contains glowing stardust in a magical way. It doesn't mean the stars chose you, or that every iron atom can be traced to one known explosion. Science is more careful and more beautiful than that. It says that the elements needed for life were produced and spread through generations of cosmic change, and that Earth, like you, is made from material that passed through older chapters of the universe. The same matter has been transformed again and again. What was once inside a star became part of space. What drifted through space became part of a forming planet. What entered the planet became part of geology, water, food, and living tissue. And what now travels through your veins may someday return to the wider world in another form. This is not a story of ownership. It is a story of participation. Your blood is temporary, but the atoms inside it are ancient travelers. They have changed homes many times, and for a little while, they help make your life possible. Perhaps that is why the body can feel both fragile and vast. Fragile, because it depends on tiny balances. Enough iron but not too much. Enough oxygen but not deprivation. Enough blood flow reaching each hidden corner. Vast, because those tiny balances are built from matter with a cosmic past. You are not only a person walking through time, you are time gathered into a body. You are the universe made warm, wet, and aware. And the next time you see a drop of blood, do not see only something human. See a red signal from deep history. See a star's old work continuing in a quiet vessel. See oxygen being carried by ancient iron through the soft darkness under your skin. And maybe for a moment, being alive will feel less like an isolated accident and more like a continuation of something enormous, a chain of fire, collapse, dust, planet, body, breath, and heartbeat, all flowing through you in the color red. Your body glows too weakly for your eyes to see. You are glowing right now, but the light is so faint that darkness itself hides it from you. Not glowing like a candle, not glowing like a screen, not glowing in the mystical sense that turns biology into fantasy, but glowing in a real, measurable way. Your body releases tiny amounts of visible light, far too weak for the human eye to detect. If you sit in a completely dark room, you will not see your hands shining. You will not see your face surrounded by a halo. There is no secret aura made visible by belief, but with extremely sensitive cameras designed to catch single faint traces of light, scientists have measured what is often called ultra-weak photon emission from living tissue. It is one of those facts that sounds invented until you understand the mechanism. Your body is full of chemical reactions. Every second, cells are breaking down food, using oxygen, making energy, repairing damage, building molecules, sending signals, and managing the delicate chemistry that keeps life from falling apart. In the middle of this constant activity, some reactions produce molecules in excited states, meaning they briefly hold extra energy. When those molecules relax back down, a tiny amount of that energy can be released as light. The result is not bright enough to guide you through a room. It is not even close. It is more like a whisper of light, a faint biological afterglow from the chemistry of being alive. And that is what makes it so beautiful. Your glow is not decoration. It is a side effect of metabolism, of oxygen, of molecular motion, of the fact that your cells are constantly working in the dark. Much of this ultra-weak light is linked to oxidative processes. Oxygen is essential for human life because your cells use it to extract energy from nutrients. But oxygen chemistry is also reactive. During normal metabolism, especially in the energy-producing activity of cells, reactive molecules can form. Your body has antioxidant systems to manage them, because too much oxidative stress can damage proteins, fats, and DNA. But ordinary life always involves a balance between chemical creation, chemical stress, and chemical repair. Some of the faint light your body releases may arise from these reactions involving lipids, proteins, and other molecules as they shift energy states. In a way, your body's invisible glow is a soft trace of the work required to keep you alive. It is not a sign that something supernatural is happening. It is a reminder that biology is never still, even when you are resting, even when you feel quiet. Even when you are lying in bed with your eyes closed, your cells are busy enough to produce light your eyes are too limited to notice. Human vision is remarkable, but it is not absolute. Your eyes are built to help you survive in the world, not to reveal every tiny signal nature produces. They need enough light to activate the cells in the retina and send meaningful information to the brain. The glow from your body is far below that threshold. It is like trying to hear a single snowflake land during a thunderstorm. The signal is real, but your senses are not made for it. This is why scientific instruments matter. They extend the body's perception. A sensitive camera can sit in darkness and collect faint photons over time, gathering what your eyes cannot gather. In some experiments, researchers have found that different parts of the body can emit slightly different amounts of this light, and that the intensity may change with time of day, activity, metabolism, and physiological state. The face, for example, may show measurable patterns because exposed skin, blood flow, temperature, and metabolic activity all shape the tiny signals coming from tissue. But we must be careful here. This glow is not a simple diagnostic lamp that tells the whole truth about a person. It does not reveal your soul. It does not prove someone has a special energy field. It is a subtle biological signal, interesting because it connects light to chemistry, not because it gives us permission to invent false stories. The real science is already strange enough. Think about what this means. Life is not only matter arranged into organs. It is also energy being transformed continuously. Food becomes movement, breath becomes cellular work, oxygen becomes part of a controlled fire that never bursts into flame. Your body is warm because chemical energy is being released. Your cells are active because molecules are constantly changing partners, breaking, bonding, folding, unfolding, carrying, and releasing. The faint light is one tiny leak from that enormous hidden industry. It is the body's quiet shimmer at the edge of detection. You could live your whole life without knowing it exists, and yet it has always been there, accompanying you through sleep, fear, hunger, healing, aging, and thought. It may even feel poetic to say that the body glows, but the deeper lesson is not that you are secretly luminous in a magical way. The deeper lesson is that your senses give you only a softened version of reality. The body contains events too small, too dim, too fast, or too hidden for ordinary awareness. You feel like a solid person moving through the day, but beneath that simple experience is chemistry flashing. Ions moving, blood flowing, cells repairing, heat spreading, and faint photons escaping unnoticed into the dark. You are not aware of most of yourself. You live on the surface of a vast inner world, and perhaps that is why this fact is so quietly powerful. It changes the way you imagine aliveness. A living body is not just a shape. It is not just skin, muscle, bone, and breath. It is a controlled storm of energy, delicate enough to hold consciousness, organized enough to heal wounds, and active enough to glow more than nothing, even if less than sight can see. The glow is weak, but it is honest. It says that life is happening here. It says that chemistry is not cold when it becomes a body. It says that even in darkness, the living world is not completely dark. So the next time you look at your hands in a dim room and see only shadow, remember that your eyes are missing something. Beneath the silence of the surface, your cells are giving off tiny traces of light, like distant stars behind a cloudy sky. You do not shine because you are separate from nature. You shine because you are nature, arranged into a body that burns gently without flame, works constantly without applause, and releases from the deep labor of living, a glow too quiet to be seen, but real enough to remind you that even your darkness is full of activity. Your liver can regrow part of itself. The liver is one of the few organs in your body that can lose a piece of itself and still begin rebuilding, as if life has hidden a repair plan inside its deepest tissue. This sounds almost mythical at first, like a story borrowed from ancient legends, but it is real biology, and the truth is even more interesting than the myth. Your liver does not regrow like a lizard's tail, forming a perfect copy of the missing part in the exact same shape. Instead, it performs something more practical and more astonishing. The remaining tissue enlarges, its cells multiply, and the organ restores enough mass and function to keep the body alive. After part of the liver is surgically removed, or after a living donor gives a portion of their liver to someone else, the remaining liver tissue can grow significantly over the following weeks and months. This is one reason living donor liver transplantation is possible. A healthy person can donate part of the liver, and both the donor's remaining liver and the recipient's transplanted portion can grow toward the size needed for their bodies. Not instantly, not without risk, not like magic, but through a highly coordinated biological response involving cell growth, blood flow, chemical signals, and the liver's unusual ability to re-enter a rebuilding state. Most organs do not behave this way so dramatically. If part of the heart is badly damaged, it often heals with scar tissue rather than replacing all lost muscle. If neurons in certain parts of the brain are lost, they are not simply rebuilt in large numbers. But the liver is different. Its main cells, called hepatocytes, are normally busy doing the daily work of metabolism, processing nutrients, handling toxins, producing bile, storing energy, helping regulate blood chemistry, and making important proteins. Yet when the liver loses tissue, many of these cells can begin dividing again. They do not remain frozen in one role forever. They can respond to need. It is as if the liver has kept a quiet emergency memory from early development, a readiness to grow when survival demands it. But But this ability exists because the liver's job is so essential that the body cannot easily tolerate its failure. The liver is like a central laboratory, factory, filter, warehouse, and chemical manager all at once. It receives blood from the digestive tract, rich with nutrients, medicines, alcohol, bacterial products, and substances absorbed from food. It sorts, transforms, stores, breaks down, and releases what the body needs. It helps turn excess glucose into stored energy and later helps release energy when blood sugar falls. It produces bile, which helps digest fats. It makes proteins needed for blood clotting, meaning that without liver function, even bleeding control can become dangerous. It helps process many drugs not by detoxing in the vague way wellness advertisements often use the word, but through real enzyme systems that chemically modify substances so they can be used, neutralized, or removed. This is why liver damage can affect so many parts of the body at once. When the liver is healthy, much of its work is invisible. You do not feel it interpreting the chemistry of your last meal. You do not feel it preparing bile. You do not feel it adjusting proteins in your blood. You simply continue. But if the liver is overwhelmed by disease, chronic alcohol injury, viral infection, severe fat buildup, toxins, blocked bile flow, or scarring, the whole body begins to feel the consequence. And this is where the liver's regenerative power has an important limit. A liver can regrow after injury or surgery if the remaining tissue is healthy enough, and if the damage has not destroyed the organ's architecture. But repeated injury can lead to fibrosis and cirrhosis, where scar tissue changes the liver's structure and blocks normal function. In that state, regeneration may become disorganized or insufficient. The liver may try to repair, but the landscape it must repair within has become distorted. This distinction matters because the liver's ability to regrow is not permission to abuse it. It is not invincible. It is resilient, but resilience is not the same as endless forgiveness. The same organ that can rebuild after losing part of itself can also be slowly trapped by long-term damage. Its strength is real, but it depends on conditions. When liver regeneration begins, the process is not controlled by one simple command. It is more like an orchestra responding to a sudden silence. Blood flow changes because the same amount of blood may now move through less tissue, creating mechanical signals. Immune cells and liver cells release chemical messages. Growth factors help tell cells to divide. Energy use shifts. The remaining liver tissue expands its working capacity. Cells that were quietly performing ordinary duties enter a more active state, not because they have forgotten what they are, but because they know what must be restored. There is something deeply beautiful about this kind of repair, because it shows that the body is not just built once and then left to decline. It contains response systems. It measures loss, it senses pressure, it recalculates what is needed. It does not rebuild out of pride. It rebuilds because function must continue, and perhaps that is the most powerful way to understand the liver. Not as a symbol of purity, not as a mysterious detox machine, but as a disciplined organ of adaptation. It accepts everything coming from the gut and does the patient work of transformation. It takes the raw materials of living, food, chemicals, waste products, medicines, hormones, and turns chaos into usable order. It is not glamorous. It does not announce itself with a beat like the heart or a thought like the brain. It works in the background, in quiet chemical sentences, keeping the internal world stable enough for consciousness to feel effortless. And when part of it is removed, it does not mourn the lost shape. It asks what remains and begins from there. That may be the lesson hidden inside its biology. Healing is not always returning to exactly what was. Sometimes healing is restoring enough function to continue. Sometimes the body does not recreate the old form. It builds a new balance. The liver teaches that life can survive by reorganizing, not by pretending nothing happened. It can lose, respond, expand, and keep working. Yet it also teaches humility, because repair has limits and care matters before crisis arrives. The organ that can regrow part of itself still needs protection. From avoidable toxins, from untreated infections, from excess alcohol, from metabolic strain, from neglect disguised as normal life. So when you think of your liver, do not imagine only a hidden mass beneath the ribs. Imagine an organ quietly negotiating with everything you consume, everything your body stores, everything it must break down, and everything it must build. Imagine a living workshop that can be wounded and still begin again. Imagine a piece of tissue with enough memory of growth to recover what many organs cannot. And maybe, in that quiet fact, there is a softer human truth as well. You are alive because parts of you know how to begin again without asking your permission. Beneath your awareness, your liver keeps working, sorting, repairing, adapting, and if it must, rebuilding from what remains. Your nose can detect thousands of odors. A scent can reach your past faster than a photograph. Before you have time to explain it, before you can name the molecule in the air or understand why your chest suddenly tightens, your nose can pull a memory out of the dark and place it in front of you with startling force. A childhood kitchen, rain on hot pavement, old books, a hospital hallway, someone's shirt, a summer room you thought you had forgotten. Smell is often treated as a small sense, less important than sight or hearing. Something decorative that makes flowers pleasant and smoke alarming. But your nose is far more powerful than it seems. It is not just an opening for breath. It is a chemical listening device, a soft gateway where the outside world dissolves into invisible signals and becomes experience. Every odor begins with molecules drifting through the air, too small to see, released from coffee, soil, skin, fruit, wood, smoke, perfume, rain, food, flowers, metal, paper, and thousands of other sources. When you inhale, some of those molecules travel high into the nasal cavity, where they meet a specialized patch of tissue called the olfactory epithelium. Hidden there are sensory neurons with receptors that can recognize features of odor molecules. Humans have around 400 types of functional odor receptors, and that may sound small compared with the richness of everything you can smell, but the system works through patterns. One odor molecule can activate more than one receptor, and one receptor can respond to more than one molecule. The brain does not read smell like a single label on a jar. It reads a combination, a pattern of activity, a kind of chemical chord. Just as a few musical notes can be arranged into countless melodies, a few hundred receptor types can help produce an enormous range of scent experiences. That is why your nose can detect thousands of odors, and researchers debate whether human smell may be capable of distinguishing far more under certain conditions. What matters most is not the exact number, but the principle. Your sense of smell is not weak or simple. It is a vast pattern recognition system, constantly sampling the chemical atmosphere around you. And unlike vision, which depends on light, smell depends on physical traces of things themselves. To smell coffee, tiny molecules from the coffee must enter your nose. To smell rain on dry earth, molecules released from soil and plants must ride the air toward you. To smell another person, you are detecting chemical traces from their body, clothing, environment, and habits. In this sense, smell is intimate. It is contact at a distance. It lets the world enter you quietly. Once odor signals are detected, they travel to the olfactory bulb, a structure near the front of the brain that helps organize the information. From there, smell has unusually direct connections to brain regions involved in emotion and memory. This is one reason a scent can feel so immediate, so personal, so difficult to translate into words. You may struggle to describe an odor, yet recognize it instantly. You may not remember the name of a place, yet one smell can bring back the feeling of being there. The brain's language systems are not always good at capturing smell. We often describe odors by their sources: smoky, floral, citrus, ocean, leather, bread, rain. But the experience itself is deeper than the word. It is not just identification, it is atmosphere. Smell gives emotional color to space. A room can feel clean, safe, stale, warm, dangerous, familiar, or strange before you consciously know why. This is part of why smell is so important for survival. Long before scientific labels, animals needed to detect food, decay, fire, predators, mates, illness, territory, and environmental danger. Your nose still carries that ancient purpose. It can warn you of smoke before you see flames, spoiled food before you eat it, gas leaks when odorants are added for safety, or chemical irritation before damage becomes worse. Smell is not only pleasure, it is protection, but it also shapes flavor far more than most people realize. Much of what you call taste is actually smell working from behind the mouth. Your tongue can detect basic taste qualities such as sweet, salty, sour, bitter, and savory, but the detailed flavor of chocolate, garlic, coffee, strawberries, roasted meat, mint, or cinnamon depends heavily on aroma molecules traveling from the back of the throat into the nasal cavity while you chew. This is called retronasal smell. When your nose is blocked during a cold, food can seem strangely flat, not because your tongue has stopped working, but because the aromatic dimension has gone quiet. The world of flavor loses its depth. It becomes a painting with most of its colors removed. Your nose also adapts quickly. If you walk into a room with a strong smell, it may feel intense at first, then fade after a few minutes. The smell has not necessarily disappeared. Your nervous system has adjusted to it, reducing attention to a constant signal so it can notice changes that may matter more. This is why you may stop noticing your own home's scent, but immediately notice someone else's. Your brain is designed to detect difference, not to keep shouting about the familiar. And this creates a strange blind spot. You live inside chemical environments all the time, but only become aware of them when something shifts. Smell is always there, quietly shaping your sense of place, even when it has become background. It is also deeply individual. People vary in how sensitive they are to different odors. Some can detect certain smells strongly, while others barely notice them. Genetics can shape which odor receptors you have and how they respond. Experience matters too. A smell that comforts one person may disturb another because it is tied to memory. Culture, food habits, environment, and personal history all influence what smells pleasant, disgusting, meaningful, or neutral. Even attention can change smell. When you focus on an odor, it may become more detailed. When you are distracted, it may vanish into the edges of awareness. And when smell is lost, as in anosmia, people often discover how much of the world was carried by it. Losing smell can affect appetite, safety, emotional connection, and the feeling of being present in a place. It can make the world seem thinner, less textured, less alive. This reveals something important. Smell is not a minor decoration added onto reality. It is one of the ways reality becomes intimate. It gives the air a memory. It gives objects a hidden identity. It gives people, seasons, homes, and cities an invisible signature. Your nose is not simply detecting good or bad smells. It is reading fragments of chemistry and handing them to the brain as meaning. That meaning can become warning, hunger, comfort, longing, disgust, desire, grief, or recognition. And perhaps the most beautiful part is that this entire experience begins with invisibility. You cannot see the molecules. You cannot watch the receptors respond. You cannot feel the signal travel into the brain. Yet suddenly a smell arrives and something inside you knows. A bakery at dawn becomes warmth. Cut grass becomes summer. Smoke becomes alertness. A familiar perfume becomes a person who is not there. The nose turns chemistry into presence. It proves that the world is always giving off traces of itself, and your body is always quietly reading them. So the next time a scent stops you without warning, do not treat it as a small accident. It may be one of the oldest senses you have, reaching beneath language, beneath logic, beneath the neat surface of thought, and reminding you that memory is not only stored in images, and reality is not only what can be seen. Sometimes the deepest door into the past is opened by something you cannot see at all, drifting through the air, entering with a breath, and becoming, for one strange second, a whole world returned. Your eyes are an extension of the brain. Your eyes are not windows that simply let the world in. They are pieces of your brain reaching outward to touch light. That sounds strange because we usually imagine the eyes as cameras mounted on the face, collecting images and sending them somewhere deeper for the mind to inspect. But biology tells a more intimate story. During early development, the retina does not form like an ordinary patch of skin that later learns to see. It grows out from the developing brain itself. The light-sensitive layer at the back of your eye is part of the central nervous system, and the optic nerve is not just a wire in the simple mechanical sense. It is more like a living tract of brain tissue carrying visual information inward. In other words, when you look at the world, the brain is not waiting far away in the dark for a finished picture to arrive. A part of the brain is already there at the back of each eye, beginning the work before you are aware of anything at all. Light enters through the cornea, passes through the lens, and falls onto the retina, but the retina does not behave like a passive screen. It is an active processor. It receives photons, converts them into electrical signals, compares patterns, emphasizes edges, detects contrast, separates changes from background, and begins organizing the visual world before the signal travels deeper into the brain. By the time information leaves the eye, it has already been interpreted. This is why the phrase, "seeing with your eyes," is only partly true. You see with a system: eye, retina, optic nerve, thalamus, visual cortex, attention, memory, expectation, and movement working together. Your eyes collect light, but your brain builds sight. Inside the retina are photoreceptors called rods and cones. Rods are extremely sensitive and help you see in dim light, though they do not give sharp color detail. Cones work best in brighter light and help with detail and color vision. These cells do not send little photographs to the brain. They respond to light by changing chemical and electrical activity, turning the outside world into nerve signals. Then other retinal cells begin sorting those signals. Some cells respond strongly to changes in brightness. Some help compare nearby areas. Some are involved in motion and timing. This early processing is one reason you can detect a tiny movement in the corner of your vision before you know what moved, or notice a sharp boundary between object and background faster than you can describe it. Vision is not just receiving. It is selection. It is compression. It is decision-making at the edge of awareness. And your eyes are built with astonishing compromises. At the center of your vision is a small region called the fovea, where cone cells are packed densely and detail is highest. This is why you move your eyes constantly, even when you feel still. You are not seeing the whole scene in perfect sharpness at once. Your brain creates that impression. In reality, your eyes make tiny, rapid movements, gathering high-resolution pieces from selected points, while the brain combines them with peripheral information and memory into a stable experience. Your peripheral vision is better at detecting motion and broad shapes than fine detail. That is useful because survival often depends on noticing movement before identifying it. A sudden shift at the edge of your sight might be a falling object, an approaching animal, a car, a person, a threat, or a chance to act. Your visual system is not designed to show you the whole world equally. It is designed to prioritize what may matter. There is even a place in each eye where you cannot see at all, the blind spot, where the optic nerve exits the retina and there are no photoreceptors. You almost never notice it because the brain fills in the missing area using surrounding information and input from the other eye. This quiet patching is so seamless that it feels like certainty. The world appears complete, but completion is partly constructed. And this is where the eye becomes a lesson in humility. What you experience as vision is not raw reality entering you unchanged. It is a collaboration between light and tissue, between signals and prediction, between what is present and what the brain expects should be there. The eyes also reveal how closely seeing is tied to movement. You might think vision is something that happens while you sit still and watch, but your visual system is built for an active body. Your eyes jump several times per second in tiny movements called saccades, scanning the world. Between those movements, the brain stabilizes the image so the world does not seem to smear or jump. When you walk, turn your head, reach for a cup, or read a sentence, your eyes and brain coordinate with muscles and balance systems to keep the world usable. Sight is not just for admiring, it is for action. It helps you judge distance, avoid obstacles, recognize faces, guide your hands, track danger, and orient yourself in space. Two eyes also give your brain slightly different views of the world, and by comparing them, it can estimate depth. This is not the only depth cue you use, but it is one of the most immediate. The world becomes three-dimensional, not because the eyes deliver depth as a simple object, but because the brain calculates relationships from differences, shadows, size, motion, and experience. Even the simple act of focusing on something close or far is a physical negotiation. The lens changes shape, the pupils adjust. The eyes turn inward or outward slightly depending on distance. You do not consciously manage these movements, yet your sense of a stable world depends on them. And because the retina is part of the nervous system, the eye can also reveal something about the body's inner condition. Doctors can look through the pupil and see blood vessels in the retina, one of the rare places where small blood vessels can be observed directly without cutting into the body. Changes in the retina can sometimes reflect conditions like diabetes, high blood pressure, inflammation, or neurological disease. The eye is therefore not only a sensory organ, it is a visible extension of internal health, a place where the hidden circulation and nervous system come close enough to the surface to be examined. This makes the eye feel almost symbolic, but again, the real biology is more powerful than the symbol. Your eyes are delicate neural instruments exposed to the world, protected by lids, tears, reflexes, and bone, yet constantly open to light. Tears are not only signs of emotion, they help keep the surface moist, smooth, and defended. Blinking refreshes the tear film and clears small irritants. The pupil changes size to control how much light enters. The lens bends light so it lands more precisely on the retina. The cornea provides much of the eye's focusing power. Every clear moment of sight depends on many structures working together with quiet precision. And still, the final experience of seeing is not located in the eyeball alone. Damage to the visual cortex can affect sight even when the eyes themselves are intact. Damage to the eye can deprive the brain of input even when the mind is awake and ready. Vision belongs to the relationship between them. So, when you open your eyes in the morning and the room appears around you, remember that this simple moment is not simple at all. Your brain has extended itself to the edge of your face, caught light through transparent tissue, translated photons into signals, filtered patterns, corrected gaps, stabilized movement, shaped depth, and delivered a world that feels immediate. You do not merely look out from behind your eyes. A living part of your nervous system is meeting the world first, touching light before thought can speak. And perhaps that changes what sight means. To see is not to possess reality. It is to participate in a delicate exchange between the universe and your nervous system. Light leaves surfaces, enters the eye, becomes electricity, becomes pattern, becomes recognition, becomes meaning. A face becomes someone you love. A shadow becomes caution. A horizon becomes distance. A word becomes thought, and all of it begins with the strange fact that your eyes are not separate from the mind that sees. They are the brain's quiet scouts, soft and fragile, facing outward into brightness, gathering pieces of the world so that, inside the dark of your skull, reality can appear. Your lungs contain a huge surface area. Each breath opens a hidden landscape inside your chest, far larger than the size of your body suggests. You inhale and feel almost nothing more than air moving through your nose, your throat, your ribs gently widening, your chest rising by a small amount. And because the motion feels so simple, it is easy to imagine the lungs as two soft bags filling and emptying like balloons. But your lungs are not empty bags. They are branching worlds. They are living forests turned inward, made not of leaves reaching towards sunlight, but of airways dividing again and again into smaller passages until they end in hundreds of millions of tiny air sacs called alveoli. These alveoli are the reason your lungs can fit inside your chest and still contain an enormous surface area, often estimated to be around the size of a small room or a tennis court-like space when spread out, depending on body size and how it is measured. That may sound impossible until you remember that nature often creates vastness by folding, branching, and repeating small structures. A sheet of paper takes up little space when crumpled. The intestines gain surface through folds. The brain gains area through grooves. And the lungs create their own quiet miracle by turning breath into architecture. Each alveolus is tiny, but together they form a vast internal shoreline where air and blood come close enough to trade gases. This is the true purpose of all that hidden surface. Your body does not simply need air inside it. It needs oxygen to cross from the air into the bloodstream and carbon dioxide to leave the blood and return to the outside world. For that exchange to happen efficiently, the lungs need three things: a large surface, a very thin barrier, and a constant supply of blood moving past the air spaces. The alveoli provide the surface. Their walls are extremely thin, and around them lies a dense network of capillaries, tiny blood vessels so narrow that red blood cells often pass through in single file. In this delicate meeting place, air and blood do not mix, but they come separated by such a fine boundary that gases can diffuse across it. Oxygen moves from the air in the alveoli into the blood because its concentration is higher there, while carbon dioxide moves in the opposite direction because it is higher in the blood arriving from the body's tissues. You do not need to command this exchange. You do not need to think, now oxygen should enter, or now carbon dioxide should leave. The movement follows physical gradients quietly and continuously every time you breathe. But the simplicity of the principle hides the elegance of the design. If your lungs had only a few large chambers, there would not be enough surface for the body's needs. You might move air in and out, but the exchange would be too limited. Instead, the lungs divide air into countless tiny pockets, maximizing contact with blood while keeping the whole organ soft enough to expand and recoil. The alveoli must also remain open, which is harder than it sounds. Tiny wet air sacs can collapse because of surface tension, so the body produces a substance called surfactant that helps reduce that tension and keeps the alveoli from sticking shut. Without enough surfactant, breathing becomes much more difficult, especially in premature infants whose lungs may not yet produce enough of it. This shows how breathing depends not only on air, but on microscopic chemistry at the surfaces where air meets fluid. The lungs are moist inside because gases must dissolve slightly before crossing tissues, yet that moisture creates physical challenges that the body has learned to solve. And all of this happens inside a structure that must also protect itself from the outside world. Every breath brings in more than oxygen. It can carry dust, pollen, smoke, pollution, microbes, and tiny particles from the environment. So the lungs are built with defenses, hairs and mucus in the upper airways, cilia that help move trapped particles upward, immune cells that patrol deeper spaces, and cough reflexes that can force irritants out. But the deepest gas exchange surfaces must remain thin and delicate, because if the barrier becomes too thick, oxygen has a harder time crossing. That is why lung diseases that damage alveoli, scar tissue, flood air spaces with fluid, or narrow airways can make breathing feel so frightening. They do not merely block air like a closed door. They reduce the body's ability to use the vast inner surface on which life depends. In emphysema, for example, alveolar walls can be destroyed, reducing surface area and making gas exchange less efficient. In pneumonia, air spaces can fill with fluid and inflammatory material. In pulmonary fibrosis, scarring can thicken and stiffen the lung tissue. In asthma, airways can narrow and become inflamed, making it harder for air to reach the places where exchange happens. The hidden landscape changes, and suddenly the breath you once ignored becomes work. This may be one of the most humbling things about the lungs. When they function well, they disappear from your awareness. You can spend hours, days, years breathing without gratitude, because the process is so reliable that it becomes background. The diaphragm contracts beneath the lungs, the chest cavity expands, air flows inward, the lungs stretch, alveoli fill, gases exchange, muscles relax, air flows outward, and you continue. Again and again, roughly every few seconds, even during sleep, even while you are lost in thought, even while you forget you are a body at all. And yet this quiet rhythm is not passive. The lungs are constantly balancing openness with protection, thinness with strength, moisture with stability, exposure with defense. They must be open enough to the world to receive air, but guarded enough to keep the world from harming the delicate inner surface. They are one of the most intimate borders you have, because breathing means allowing the outside world into the deepest practical edge of the body. With every inhale, the environment enters you. With every exhale, part of your inner chemistry returns to the air. You are not sealed off from the world. You are exchanging with it moment by moment through a surface hidden in your chest. And perhaps this is what makes the lungs so quietly poetic without needing exaggeration. Inside you is a folded horizon, a soft and branching space where the atmosphere meets the bloodstream, where the invisible becomes usable, where a breath becomes energy, speech, movement, warmth, attention, and life. You do not carry a huge surface area in your lungs because nature wanted excess. You carry it because being alive is demanding. Every cell in your body depends on a system that can gather enough oxygen from a thin layer of air and release enough carbon dioxide before it builds up. So the lungs turned smallness into vastness. They folded space into tissue. They built an inner coastline so wide that each breath could touch enough of the world to keep you here. The next time you inhale, try to remember that you are not simply filling 2 bags with air. You are opening millions upon millions of tiny rooms. You are sending air down a branching tree. You are letting the sky reach a hidden surface inside you. And on that surface, without sound or ceremony, your body continues its oldest agreement with the world. You give me air, and I will turn it into another moment of life. Your blood vessels could stretch enormous distances. Your body contains roads so small and so numerous that, if they could be laid end to end, they might stretch farther than many journeys you will ever take in your lifetime. This is one of those facts that sounds impossible because you live inside the body as if it were compact, bounded, familiar, a shape that fits into clothes, chairs, beds, rooms, mirrors, and yet hidden within that ordinary shape is a branching transport system of astonishing scale. Your blood vessels are not just a few tubes carrying blood from one place to another. They are an immense living network of arteries, veins, and capillaries reaching almost everywhere tissue needs oxygen. Nutrients, hormones, immune cells, heat regulation, waste removal, and chemical communication. Many popular estimates say that if all the blood vessels in an adult human body were stretched out, they could reach tens of thousands of miles. Often around 60,000 miles or about 100,000 kilometers, though the exact number is difficult to measure and varies with body size, age, method, and what is counted. The point is not the exact distance like a number carved into stone. The point is the design. Your body has folded an enormous delivery system into a space small enough to walk around with, and most of that length does not come from the large vessels you imagine. The thick arteries pulsing near the heart, or the blue-green veins visible beneath the skin. It comes from capillaries, the microscopic vessels so narrow and widespread that they turn your body into a living map of exchange. Arteries carry blood away from the heart under higher pressure, built with strong elastic walls that can stretch and recoil with each pulse. Veins return blood toward the heart under lower pressure, often using valves and the squeezing action of nearby muscles to help blood move against gravity, especially from the legs. But capillaries are where the deepest intimacy happens. Their walls are incredibly thin, often just a single layer of cells, allowing substances to move between blood and tissue. Oxygen can leave the blood, carbon dioxide and other waste products can enter it, nutrients can pass outward, hormones can reach their targets, immune cells can receive signals about trouble nearby. In the capillaries, circulation stops being only motion and becomes conversation. The blood is no longer merely traveling. It is delivering, collecting, listening, responding. Every patch of living tissue depends on this closeness. A muscle cannot work for long without receiving what it needs. A wound cannot heal properly without blood supply. A gland cannot send its chemical messages without access to circulation. Even the brain, which is deeply protected, depends on a dense and carefully regulated blood supply because nerve tissue is extremely sensitive to interruptions. This is why blood vessels are not passive plumbing. They are living organs in their own right, lined by a delicate inner layer called the endothelium. This inner lining is far more than a smooth surface. It helps regulate vessel widening and narrowing, influences clotting, responds to inflammation, communicates with the immune system, and helps maintain the boundary between blood and surrounding tissue. The vessels can change diameter depending on need. During exercise, blood flow can increase to active muscles. In cold conditions, vessels near the skin may narrow to conserve heat. In warmth, they may widen to help release heat. After a meal, more blood flow can support digestion. During fear or sudden stress, circulation can be redirected towards systems needed for rapid action. Your vessels are constantly adjusting the geography of flow, deciding where pressure should rise, where resistance should fall, where warmth should be kept, where repair is needed. You do not feel most of these decisions. You simply continue, while the hidden roads inside you open and narrow like a city responding to changing traffic. And unlike roads made of concrete, blood vessels can grow, remodel, and adapt. When tissues need more supply, the body can form new small vessels through a process called angiogenesis. This is important in healing and growth, but it can also be involved in disease, such as when tumors encourage new blood vessels to feed their expansion. Again, biology is rarely simply good or bad. The same power that helps repair can be misused by illness. The same circulation that sustains life can spread infection or carry harmful substances if the body is exposed to them. The same clotting system that saves you from bleeding too much after injury can become dangerous if a clot forms where it should not. The vascular system is therefore a system of balance. Flow without leakage, pressure without rupture, clotting without blockage, openness without invasion, delivery without chaos. And this balance is astonishing because the network is so vast. Blood must travel through large highways, medium branches, tiny side streets, and microscopic alleyways, all while maintaining enough pressure to move, but not so much that delicate vessels are damaged. The heart may be the pump, but the vessels shape the journey. They determine resistance, they cushion pressure, they distribute flow, they make sure the body is not treated as one uniform object, because different tissues have different needs at different moments. Your skin, kidneys, brain, muscles, gut, and lungs are not all asking for the same thing at the same time. The vascular system listens to those changing demands in the language of pressure, chemicals, oxygen levels, temperature, and local signals. Perhaps this is why the image of blood vessels stretching enormous distances feels so powerful. It reminds you that smallness can create vastness. A capillary is tiny, almost unimaginable to ordinary sight, yet multiplied through the body it becomes a hidden continent. Your body is not large because it occupies much space. It is large because it contains so many inner paths. You are full of roots no traveler will walk, bridges no eye will see, rivers thinner than hair carrying life to places you never think about. When you sit quietly, blood is still moving through fingertips, eyelids, kidneys, muscles at rest, the lining of the gut, the roots of hair, the marrow inside bones, and countless living neighborhoods that would suffer if the roads went dark. And maybe this changes how you imagine being alive. You are not a solid object with blood inside it. You are a moving distribution system organized into the shape of a person. You are circulation wrapped in memory, vessels carrying warmth under skin, pressure waves moving through elastic walls, microscopic exchanges happening in silence so that thought, motion, healing, digestion, touch, and attention can continue. The distance hidden inside you is not there for spectacle. It is there because life is local. Every cell needs its own nearby access to the larger body. No cell can simply trust that the heart is beating somewhere far away. It needs a vessel close enough for exchange. So the body builds closeness by creating length. It threads itself with pathways until almost no living part is truly alone. And the next time you see a vein beneath your wrist or feel your pulse in your neck, remember that you are touching only the visible edge of an enormous unseen map. Beneath the surface, thousands upon thousands of branching roots are carrying the materials of survival through you, not in a straight line, not as one road, but as a living geography of movement. You are not just standing in the world. A world of roads is standing inside you. Your stomach acid can dissolve metal slowly. There is a chamber inside you strong enough to damage metal, yet gentle enough to live beside your own tissue every day. This sounds like a contradiction, almost like a trick, because when you imagine the stomach, you may think of food, hunger, fullness, maybe a growl in the quiet, but not a chemical environment powerful enough to slowly attack certain metals under the right conditions. And yet your stomach contains gastric acid, mostly hydrochloric acid mixed into a complex fluid. And this acid can be extremely strong by biological standards. Its acidity often sits around a level that would burn, sting, and corrode if it touched places in your body that were not protected. In a laboratory, hydrochloric acid can react with some metals, releasing gas and gradually dissolving material depending on the type of metal, its coating, its size, how long it is exposed, and how concentrated the acid is. This does not mean your stomach is a metal-melting furnace, and it does not mean swallowing metal objects is safe or something to test. It is dangerous, and sharp or toxic objects can cause serious injury long before acid does anything meaningful. But the basic fact remains: the fluid inside your stomach is chemically harsh enough that if a small piece of reactive metal were trapped there long enough, it could be slowly changed by acid. The more astonishing question is not whether stomach acid is strong. The real question is, how does your body hold something like that without destroying itself? The answer is protection, timing, and constant repair. Your stomach lining is not helpless flesh sitting in acid. It is covered by a thick layer of mucus that acts like a slippery shield, trapping bicarbonate and helping keep the surface of the stomach much less acidic than the fluid in the open stomach cavity. Beneath that mucus, stomach cells are tightly connected, renewed, and defended by blood flow, local signals, and rapid repair mechanisms. The acid is kept where it belongs, aimed toward the meal, not toward the body. In this way, the stomach is like a controlled storm behind glass. Its power is useful only because it is contained. If that protective barrier weakens, acid and digestive enzymes can injure the lining, contributing to ulcers, inflammation, pain, or bleeding. This is why the stomach's strength is never simple strength. It is strength held inside boundaries. Gastric acid has several important jobs. It helps unfold proteins in food, making them easier for enzymes to break down. It helps activate pepsin, an enzyme that begins protein digestion in the stomach. It can kill or weaken many microbes that enter with food, though it does not sterilize everything, and some organisms are adapted to survive harsh conditions. It also helps with the absorption of certain nutrients by changing minerals into forms the body can use more easily. So the acid is not there as a mistake. It is part of an ancient digestive strategy. Before food can become part of you, it must be softened, unfolded, tested, and transformed. A piece of bread, a bite of meat, a spoonful of yogurt, a fruit, a grain, all enter the same dark muscular chamber and become part of a chemical and mechanical process. The stomach churns, squeezes, mixes food with acid and enzymes, and turns it into a softer mixture called chyme before releasing it gradually into the small intestine. This gradual release matters because digestion is not only about breaking food down, it is about controlling the pace of what enters the next stage. Your stomach is not just a bag of acid. It is a timing organ, a mixing chamber, a gatekeeper, and a chemical bath. It knows without consciousness that a liquid meal leaves differently than a heavy meal, that fats can slow emptying, that the body must coordinate stomach movement with the intestine, pancreas, liver, and nervous system. You do not need to supervise this. You simply eat, and beneath awareness, chemistry becomes choreography. And yet, the strength of stomach acid has limits that reveal how delicate the system truly is. Some bacteria, such as Helicobacter pylori, can survive in the stomach by creating a local environment that protects them from acid. This bacterium can contribute to ulcers in some people, showing that even a highly acidic stomach is not an unbeatable fortress. Acid reflux is another reminder that location matters. Acid belongs in the stomach, but when it repeatedly moves upward into the esophagus, it can irritate tissue that is not built with the same protective mucus barrier. The same substance that is useful in one place becomes harmful in another. This is one of the body's quiet principles. Power must be placed correctly. A chemical is not simply good or bad. It depends on where it is, how much there is, how long it stays, and what protections surround it. Even the stomach's own acid-producing cells do not pour acid into themselves. They release components through specialized pumps and channels into the stomach space, assembling the acidic environment with precision. And when the body eats, smells food, or anticipates a meal, signals can increase acid production, preparing the stomach before food fully arrives. Hunger, appetite, and digestion are not separate events. They are connected through nerves, hormones, memory, and routine. Your stomach can prepare for food because the body has learned that survival depends not only on reacting, but on expecting. The idea that this acid can slowly dissolve some metals becomes even stranger when you think about the materials of ordinary life. Metal feels stronger than the body. It seems hard, cold, durable, resistant. Flesh seems soft and vulnerable. But chemistry does not respect appearances. A soft organ can produce an environment that attacks hard matter, while surviving because it is alive, layered, responsive, and protected. Metal resists pressure, but it cannot heal itself. Your stomach lining can. Metal may be rigid, but it cannot regulate its own boundaries. Your stomach does. This is why biology often defeats intuition. The body is not strong in the way a knife is strong or a wall is strong. It is strong because it can renew, contain, signal, adapt, and repair. Its power is dynamic. Its defenses are alive, and perhaps that is the deeper lesson hidden inside the stomach. The most intense forces in your body are not always the ones you feel. You do not feel acid helping unfold proteins after a meal. You do not feel mucus defending the lining moment by moment. You do not feel cells producing protective substances, or the stomach adjusting its emptying, or the acid being made and regulated. You only notice the system when something goes wrong. Burning, nausea, pain, reflux, hunger that twists, fullness that presses. Most of the time, the stomach's chemical strength works in silence, turning the outside world into a form the body can accept. Food is not gently welcomed unchanged. It is challenged, dissolved, mixed, stripped down, and passed onward. To eat is to invite the world into a controlled acid chamber and trust the body to separate nourishment from threat. So the next time you feel hunger or hear your stomach shift softly after a meal, remember that inside you is not a simple container, but a protected chemical engine. It can hold acid strong enough to slowly damage certain metals, yet it uses that power not for destruction, but for transformation. It breaks down what you consume so that the rest of you can be built, fueled, warmed, and repaired. And in that quiet darkness beneath your ribs, life teaches one of its oldest lessons. Even something harsh can serve life, if the body knows how to hold it in the right place. Your brain has no pain, receptors of its own. The organ that creates every pain you have ever felt cannot feel pain in the way your skin, muscles, or teeth can. This is one of the strangest truths about the brain. It is the place where pain becomes experience, where warning signals are interpreted, located, colored with fear, memory, and urgency. And yet the brain tissue itself has no pain receptors of its own. If you touch something sharp, your finger sends danger signals through nerves toward the spinal cord and brain. If you burn your hand, injure your knee, bite your tongue, or feel a headache pulsing behind your eyes, it is the brain that turns those signals into the conscious feeling of pain. But if the brain itself is carefully touched, cut, or electrically stimulated during certain medical procedures, the brain tissue does not cry out in pain the way skin would. This is not because the brain is numb in the ordinary sense. It is because the soft neural tissue of the brain does not contain the kind of specialized pain-detecting nerve endings called nociceptors that are found in many other parts of the body. The brain is the interpreter, not the alarm wire. It is the place where the message arrives, not the place that usually sends pain messages about itself. And this fact becomes even more astonishing when you realize that surgeons can sometimes perform awake brain surgery, especially for tumors or epilepsy-related procedures. while the patient is conscious enough to speak, move, count, name objects, or answer questions. The scalp, skull, and protective coverings around the brain must be carefully numbed, because those areas can feel pain. But once the surgeon reaches the brain tissue itself, direct work on the brain can often happen without the patient feeling pain from the brain tissue. This allows doctors to map important regions for language, movement, or sensation, while avoiding damage to areas that matter deeply for a person's life. Imagine that for a moment. The organ that lets you say, "I am here," can be touched while you are still speaking, and the pain you might expect from the brain itself does not arrive. The body is more strange, more layered, and more carefully divided than intuition suggests. But this does not mean the head cannot hurt. It means head pain usually comes from structures around or connected to the brain, not from the brain tissue itself. The scalp, blood vessels, muscles, sinuses, nerves, and the meninges, the protective membranes surrounding the brain and spinal cord, can all be involved in pain. The dura mater, one of those tough outer coverings, is especially pain sensitive. Blood vessels in and around the head can stretch, inflame, or signal through nearby nerves. The trigeminal nerve, one of the major nerves of the face and head, plays a central role in many headache and migraine pathways. So when you feel a headache, the pain is real, but it is not usually your thinking tissue itself hurting. It is the brain reading distress from its surrounding systems, like a king inside a castle, receiving alarms from the walls, gates, and roads outside. The brain sits protected inside the skull, cushioned by fluid, wrapped in membranes, supplied by blood vessels, and connected to the body through countless pathways. Its own lack of pain receptors may seem dangerous at first. Why would the most important organ not feel damage directly? But evolution often works through practical trade-offs. The brain is already enclosed in a rigid skull, protected from ordinary touch, friction, and direct injury in a way that skin or joints are not. It does not need to detect every scrape because it is not exposed to the outside world. What matters more is that the structures protecting and supplying it can signal danger. If pressure rises, if blood vessels are irritated, if membranes are inflamed, if the skull or scalp is injured, pain can warn the organism that something is wrong. Pain is not a perfect measure of damage, and damage is not always painful in the same way. Pain is a protective experience created by the nervous system, shaped by signals, context, expectation, attention, fear, and memory. The brain does not merely receive pain like a letter dropped in a box. It constructs pain from incoming information and meaning. That is why the same injury can hurt differently depending on stress, distraction, sleep, fear, or whether you believe you are safe. Pain is not imaginary when it is shaped by the brain. It is real because the brain makes it real. This is where the fact becomes more than anatomy. The brain can create pain everywhere else while being silent about itself. It can make your chest tighten during panic, your stomach twist during dread, your jaw ache from tension, your muscles burn during effort, your heart feel heavy in grief, and yet its own tissue remains without the ordinary alarm system it uses to interpret all those states. The witness does not scream. The translator has no tongue for its own injury. And that can feel almost poetic, but the science is precise. Pain requires detectors, pathways, spinal processing, brain regions involved in sensation and emotion, and the final conscious experience that says, something is wrong here. The brain is essential for that experience, but it is not pain sensitive in the same way as the body parts it monitors. This also helps explain why brain problems can sometimes be silent until they affect function or surrounding structures. A tumor inside brain tissue may not hurt simply because it is in brain tissue, but it can cause symptoms by pressing on surrounding areas, increasing pressure, irritating membranes, affecting blood flow, or disrupting circuits that control speech, movement, vision, balance, personality, or seizures. The absence of pain does not mean absence of danger. The body's warning systems are powerful, but they are not complete. Some serious problems hurt terribly. Others whisper through weakness, confusion, vision changes, numbness, speech problems, or subtle shifts in behavior. That is why listening to the body means more than listening for pain. Pain is one alarm, not the whole security system. And perhaps the deepest lesson is that consciousness is protected by something it cannot directly feel. You live inside thoughts, images, memories, worries, plans, and dreams, all rising from tissue that does not experience pain as flesh does. The brain can produce the agony of a burn, the sharpness of a cut, the pressure of a migraine, the ache of loss, the fear of harm, and the relief when danger passes. It can turn signals into suffering and suffering into memory. It can teach you to avoid fire, rest an injured limb, protect a wound, and seek help. But if you could ask the brain tissue itself where it hurts, it would have no ordinary answer. So the next time you feel pain, remember how mysterious the experience really is. It is not just damage. It is not just a signal. It is the nervous system interpreting threat and demanding attention. And hidden behind that demand is the quiet paradox of being human. The brain, the great maker of pain, sits in darkness without pain, receptors of its own, translating the body's alarms into feeling, guarding your survival, and never quite feeling itself in the way it teaches the rest of you to feel. Your body temperature is a constant balancing act. Your body is holding a tiny climate inside itself while the world keeps trying to steal it away. You walk from shade into sunlight, from warm rooms into cold streets, from sleep into movement, from calm into fear, and through all of it, your temperature is being defended with quiet precision. It may feel ordinary to be warm, so ordinary that you rarely think about it unless fever, chills, heat, or exhaustion forces you to notice. But your body temperature is not a passive number. It is a living balance, a constant negotiation between heat made inside you and heat lost to the world around you. Most of the time, the body tries to keep its core temperature near a narrow range, not because that number is symbolic, but because the chemistry of life depends on stability. Enzymes, proteins, cells, nerves, muscles, and organs all work best within certain conditions. Too cold, and chemical reactions slow, muscles stiffen, thinking becomes foggy, and the heart can become dangerously unstable. Too hot, and proteins can lose their shape. Cells become stressed, the brain can suffer, and the systems that keep you alive begin to fail. So your body behaves like a careful guardian of an inner fire. It does not simply create heat and hope for the best. It measures, adjusts, redirects, releases, conserves, and responds. Deep in the brain, a region called the hypothalamus helps monitor temperature and coordinate many of these responses. It receives information from the body and acts like a biological thermostat, not in a mechanical, simple way, but as part of a wider network of signals involving nerves, hormones, blood vessels, skin, muscles, behavior, and metabolism. When you become too warm, your body does not wait until danger arrives. Blood vessels near the skin can widen, allowing more warm blood to move close to the surface so heat can escape into the air. Sweat glands release fluid onto the skin, and when that sweat evaporates, it carries heat away. This is why sweat cools you best when it can evaporate, and why humid weather feels so heavy. The air is already holding so much moisture that sweat cannot leave your skin as easily. So the body's cooling system becomes less efficient. Heat then feels trapped, not because the body has stopped trying, but because the environment is refusing to take the water you are offering it. When you become too cold, the body moves in the opposite direction. Blood vessels near the skin can narrow, keeping more warm blood deeper inside, closer to the organs that matter most for survival. Your muscles may begin to shiver, contracting rapidly to generate heat. The tiny muscles attached to hairs can create goosebumps, a small leftover reflex from ancestors with more body hair, when raised hairs could trap insulating air more effectively. You may curl inward, seek shelter, add clothing, move your hands, or crave warmth, because temperature regulation is not only automatic, it also changes behavior. The body asks the mind to help. You feel discomfort, so you will act. A chill is not just a sensation, it is an instruction. Heat exhaustion is not just tiredness, it is a warning. Thirst is not simply desire, It is part of the body trying to protect circulation, sweat, and cooling. And fever reveals an even stranger layer of this balancing act. When you are infected, certain immune signals can tell the brain to raise the body's temperature set point. You feel cold and shiver even though your temperature is rising, because the brain has temporarily decided that the old normal is now too low. This is why fever often comes with chills at first. Your body is not confused in a random way. It is deliberately shifting the target. A moderate fever can make the internal environment less comfortable for some pathogens and can support parts of the immune response. Though high or prolonged fever can become dangerous and should be taken seriously, fever is not simply bad heat. It is regulated heat with a purpose, though like many defenses, it can become harmful when it goes too far. This is one of the most important truths about body temperature. Balance matters more than extremes. Warmth is life-giving only within limits. Cooling is protective only within limits. The same sweat that saves you in heat can dehydrate you if fluids and salts are not replaced. The same shivering that protects you from cold can exhaust you if exposure continues. The same narrowed blood vessels that preserve core warmth can leave fingers and toes vulnerable in severe cold. Every response has a cost. Your body is constantly choosing the least dangerous option available. Even when you are doing nothing, heat is being produced inside you. Your cells generate heat as they use energy from food. Muscles produce heat when they work. The liver, brain, heart, and other organs contribute to your internal warmth through constant metabolism. You are not warm only because the world is warm. You are warm because life is a controlled release of energy. But that heat cannot simply build forever. It must be managed, moved, and released. Your skin becomes the major meeting place where internal warmth negotiates with the outside world. Air temperature, wind, humidity, water, clothing, sunlight, body fat, muscle activity, age, health, medications, hydration, and even sleep can all change how easily that negotiation happens. Water is especially powerful because it conducts heat away from the body much faster than air. This is why cold water can become dangerous even when the air would not feel as threatening, and why wet clothing in cold conditions can steal warmth quickly. Wind matters because it removes the thin layer of warm air near your skin. Sunlight matters because radiation adds heat even when the air temperature seems manageable. Your body is always interacting with physics, whether you think about it or not. And temperature also follows rhythms. It is not perfectly fixed all day. Your core temperature usually shifts across the day and night, often lower during sleep and higher later in the day, guided partly by circadian rhythms. This quiet daily wave helps connect temperature with alertness, rest, hormone patterns, and sleep timing. When your body prepares for sleep, it often releases heat through the skin, especially from the hands and feet, helping the core cool slightly. This is one reason a warm bath before bed can sometimes help sleep afterward. Not because the body remains hotter, but because warming the skin can encourage heat loss as you cool down. Again, the body's wisdom is subtle. It does not simply chase warmth or cold. It uses change to guide state. Infants, older adults, and people with certain illnesses can be more vulnerable to temperature stress because their regulation may be less efficient or their ability to respond behaviorally may be limited. This is why heat waves and cold exposure are not just uncomfortable. They can become serious public health threats. The body's balancing act depends not only on biology, but on shelter, water, clothing, rest, and care from others. A person is not separate from the climate around them. The inner climate survives because the outer world is managed well enough. Perhaps that is the deeper lesson hidden in your temperature. You feel like one stable self, but that stability is being actively defended every second. Your warmth is not guaranteed. It is maintained. It is negotiated by skin and blood, muscle and brain, sweat and thirst, behavior and instinct. You are alive because your body can keep its chemistry in a narrow zone while everything around you changes. The sun leans closer, the night cools, the room shifts, the seasons turn. You move, rest, fear, recover, sleep, wake, and still the body keeps adjusting the flame. So the next time you feel a chill run across your skin, or sweat gather on your forehead, or warmth return to your hands after cold air, remember that these are not small accidents. They are signs of a living system protecting its center. Inside you, there is no endless summer and no permanent winter. There is only balance, kept moment by moment, by a body that understands something profound before the mind ever says it. To stay alive is not to remain unchanged, but to keep returning again and again to the narrow warmth where life can continue. Your cells communicate with chemical signals. A single cell in your body is never truly alone. It is always listening for messages it cannot hear and answering in a language made of molecules. You may imagine your body as a collection of parts. A heart here, a lung there, skin at the surface, muscles beneath, organs working in their separate rooms. But beneath that familiar map is something far more delicate. A continuous chemical conversation. Your cells do not have eyes, ears, or voices, yet they still know when to grow, when to rest, when to divide, when to defend, when to repair, when to move, when to release something, when to absorb something, and sometimes when to die for the safety of the whole. They know because other cells send signals. These signals can be tiny molecules, hormones, growth factors, immune messengers, and many other chemical instructions that travel across short distances, through fluids, or through the bloodstream. One cell releases a message, another cell receives it, and if that receiving cell has the right receptor, the message begins to mean something. A receptor is like a biological lock, but not a dead mechanical one. It is part of a living surface or inner system that changes when the right chemical key arrives. When the signal binds, the cell may open channels, activate internal pathways, change which genes are used, alter its shape, release stored materials, or prepare for a new task. This is how a wound becomes a construction site. Damaged tissue releases distress signals. Nearby cells respond. Blood vessels change. Repair cells arrive. Growth signals help guide rebuilding. The skin does not simply close by chance. It closes because countless cells are receiving chemical instructions about danger, cleanup, structure, and renewal. This is also how the body develops before birth. A growing embryo is not shaped by a tiny architect drawing organs from the outside. Cells guide one another through signals, gradients, contact, and timing. Some chemical messages tell cells where they are, what neighbors they have, and what they might become. A cell's fate can depend on the signals around it, like a person growing up in a neighborhood that quietly teaches them what role to play. One signal at one time may encourage growth. The same signal in a different place or stage may have another meaning. Biology is not only about the molecules themselves, it is about context. A word means one thing in a whisper, another in a warning, another in a song. Cells work in a similar way. The body's chemical language depends on timing, concentration, location, receptor type, and the condition of the receiving cell. This is why the same body can be both stable and flexible. A hormone released from one gland can travel through the blood and affect distant tissues, but only cells prepared to read that hormone will respond. It is like sending a letter through an entire city, where only certain houses have the right mailbox. Insulin, for example, helps many cells respond to rising blood sugar after a meal, encouraging storage and use of energy. Adrenaline can prepare the body for sudden action, changing heart rate, blood flow, and energy availability. Growth signals can tell cells to multiply when repair is needed. Cytokines, used by immune cells, can coordinate inflammation, defense, and recovery. But these messages must be balanced carefully. Too little signaling, and the body cannot coordinate. Too much signaling, and the message becomes noise or even harm. Inflammation is useful when controlled, but damaging when it becomes chronic. Growth is essential in healing, but dangerous if cells ignore the rules and divide without proper control. Cell communication is therefore not just about sending messages. It is about knowing when to stop. Silence can be as important as speech. A healthy body depends on signals fading when their work is done, receptors becoming less sensitive when overwhelmed, and cells removing messages before they keep shouting too long. Even cell death can be part of this communication. Some cells receive or activate instructions that lead them to self-destruct in an orderly way, a process that helps shape developing tissues, remove damaged cells, and protect the body from greater danger. This is not random collapse. It is a controlled exit, a quiet sacrifice that allows the larger organism to continue. And when this communication fails, the consequences can be profound. In diabetes, problems with insulin production or response can disturb energy regulation. In cancer, cells may stop obeying signals that normally limit growth or tell damaged cells to die. In autoimmune conditions, immune communication can become misdirected, treating parts of the body as threats. In allergies, harmless substances can trigger exaggerated chemical alarms. The body is not fragile because it communicates. It is vulnerable because communication is powerful. A message sent to the wrong place at the wrong time for too long can change the whole story. Yet most of the time, this vast conversation works without your awareness. Right now, as you listen, your cells are sending and receiving instructions in darkness. Some are adjusting to nutrients. Some are responding to oxygen levels. Some are maintaining barriers. Some are clearing waste. Some are preparing for repair before you ever notice damage. Your sense of being one person depends on trillions of tiny lives behaving as if they belong to something larger than themselves. That may be the most humbling part. A cell is alive, but it is not selfish in the way a whole organism can be. It survives by listening. It becomes useful by responding. It belongs by participating in a shared chemical language. And perhaps your body is, in this way, less like a machine and more like a society so well coordinated that it feels like a single self. You do not hear the messages, but you are made from their agreement. You do not speak the molecular language consciously, but every breath, meal, scar, fever, growth, and recovery depends on it. Beneath your thoughts, beneath your skin, beneath everything you call me, there is an ancient conversation still going on, cell to cell, signal to signal, asking the same quiet question again and again. What does the whole body need now? Your DNA is packed into microscopic space. If the DNA inside one of your cells were stretched out, it would be longer than your body could ever guess from something too small to see. Hidden in the nucleus of almost every cell is a thread-like molecule that carries instructions for building and maintaining you. Yet the space it must fit into is microscopic, almost impossibly cramped. This is one of biology's quiet miracles. The body does not store its deepest information in a giant library, a visible scroll, or a hard shell protected far away from daily life. It folds it into tiny rooms. Each cell nucleus is so small that you could never see it without magnification. And yet inside it, roughly 2 meters of DNA are packed, organized, protected, accessed, copied, repaired, and read when needed. This is not a loose tangle thrown into a drawer. It is a living archive under constant management. The DNA is wrapped around proteins called histones, forming bead-like structures that help shorten and organize the long molecule. These structures fold further, loop, coil, and arrange themselves into larger patterns called chromatin. When a cell prepares to divide, the DNA becomes packed even more tightly into chromosomes, the familiar compact shapes often shown in biology images. But most of the time, DNA is not sitting there as a frozen bundle. It is dynamic. Some regions are more open, making them easier for the cell to read. Other regions are more tightly packed, kept quieter or protected. The cell is not reading every instruction at once. That would be chaos. Instead, different cells use different parts of the same genetic library. A skin cell, a liver cell, a muscle cell, and a nerve cell can contain essentially the same DNA, but they behave differently because they access different instructions. This is one of the most astonishing things about your body. Identity at the cellular level is not just about what information is present, but what information is allowed to speak. A cell becomes itself partly by choosing which pages of the genetic book remain open and which stay closed. And all of this depends on packaging. DNA packing is not only about saving space, it is also about control. If the DNA were simply stuffed into the nucleus randomly, the cell would struggle to find what it needs, copy itself correctly, repair damage, or regulate activity. Instead, the genome is organized in ways that help bring certain regions closer together, separate others, and make important sequences available at the right time. Imagine a library so large that the shelves must fold inside a single grain of dust, and yet the librarian can still find one sentence when the body needs it. That is what your cells are doing constantly. They are not conscious librarians, of course, but through chemistry, structure, and molecular machines, they manage information with a precision that makes ordinary storage seem crude. When a cell needs to make a protein, it does not usually cut out the DNA instruction itself. It makes a temporary copy of a gene in a molecule called RNA, and that copy can be used to guide protein production. This means DNA stays protected as the master archive while working copies carry messages into the cell's protein-making machinery. But even this process requires access. The right stretch of DNA must loosen enough for the copying machinery to reach it. Signals inside the cell can influence which genes are active, depending on the cell's role, the body's needs, the environment, and the stage of life. This is why the genome is not a dead blueprint. A blueprint does not respond when the weather changes. DNA does. Or more accurately, the systems around DNA respond, deciding how the information should be used. This is where a field called epigenetics becomes important. Without changing the DNA letters themselves, cells can add chemical marks to DNA or histone proteins that affect how tightly regions are packed and how easily genes are read. These marks can help cells remember their identity, respond to conditions, and maintain patterns of activity. But this should not be exaggerated into the idea that thoughts instantly rewrite your genes, or that simple habits magically transform your entire DNA. The truth is subtler and more beautiful. Your genetic information is stable enough to preserve continuity, but flexible enough in its expression to respond to life. The same archive can be interpreted differently in different contexts. And because DNA is so long and so important, it must also be protected from damage. Every day, DNA can be affected by normal chemical processes, copying errors, ultraviolet light, radiation, toxins, and other forms of stress. Cells have repair systems that detect and fix many kinds of damage. These systems are not perfect, but without them, life as you know it would not last. When a cell divides, the DNA must be copied with extraordinary accuracy, because each new cell needs its own complete set of instructions. Even small mistakes can matter depending on where they happen. Some changes are harmless. Some can contribute to disease. Some, over long evolutionary time, become part of the variation that makes life adaptable. Your DNA is therefore both a record and a risk, both inheritance and vulnerability. It carries ancient instructions shaped by countless generations, yet it must survive inside active cells that are constantly using energy, dividing, repairing, and responding to the world. The packing problem makes this even more extraordinary. The nucleus is not merely a container. It is a controlled space where information must be dense, readable, protected, and movable all at once. It is like trying to fold an entire city's roadmap into a pocket, while still being able to unfold only the one street you need without tearing the paper. And somehow, your cells do this not once but trillions of times across your body. Most of your cells hold this compressed biological library, yet you never feel its weight. You do not feel DNA coiling around histones. You do not feel genes opening and closing. You do not feel chromosomes being copied during cell division. You simply grow, heal, sleep, digest, think, move, and continue, while microscopic storage systems keep the pattern of your body available. Perhaps the deepest lesson here is that life is not only made of matter, but of organized information. Your body is not just built from atoms, it is built from instructions, timing, access, regulation, and memory written in molecular form. But DNA alone is not you in the full sense. DNA is not a soul, not a destiny, not a complete explanation of personality or experience. It is a powerful set of biological instructions interpreted by cells, shaped by development, environment, chance, and history. You are not merely your genes, but without that packed archive, your cells would not know how to make the proteins, structures, and signals that allow a human body to exist. So when you think of yourself, do not imagine only the face in the mirror or the thoughts moving through your mind. Imagine a hidden library folded into microscopic space, a long molecular thread packed so carefully that it can fit inside the nucleus and still guide the making of blood, bone, skin, enzymes, receptors, repair systems, and the countless quiet details of living. Inside almost every cell, your body carries a history older than memory and smaller than dust, folded not because it is finished, but because it must be ready. Ready to be read, ready to be copied, ready to be protected, ready to help rebuild the body again and again. And maybe that is what makes DNA packing feel so profound. The vastness of life is not always found in large things. Sometimes the most powerful instructions are hidden in the smallest rooms, folded in silence, waiting for the cell to ask the right question. Your mitochondria were once bacteria-like ancestors. Deep inside your cells, there are tiny descendants of an ancient partnership that changed the future of life on Earth. They are called mitochondria, and you may have heard them described as the powerhouses of the cell, but that phrase is so familiar that it almost hides the deeper wonder. Mitochondria are not just little energy machines sitting quietly inside you. They carry the traces of a time when life on this planet was much simpler, smaller, and more divided. When single-celled organisms filled the ancient oceans and the idea of animals, plants, brains, hearts, eyes, and human memory did not yet exist. Long before you took your first breath, long before mammals, long before forests, long before anything with a face looked out at the world, one cell appears to have taken another cell inside itself and, instead of destroying it, kept it. This was not a friendship in the human sense. It was not a choice made with awareness. It was biology discovering a new arrangement. The smaller cell was likely bacteria-like, capable of using oxygen in a powerful way to extract energy from food molecules. The larger host cell may have gained a tremendous advantage by keeping this internal partner alive, because oxygen, which had once been dangerous to many early forms of life, could now be turned into a source of more efficient energy. Over immense stretches of time, this captured partner became less independent, more integrated, and eventually transformed into what we now call the mitochondrion. This idea is known as the endosymbiotic theory, and it is one of the most beautiful explanations in biology because it says that a major step in the evolution of complex life may have come not from one organism defeating another, but from one living system becoming home to another. The evidence is not just poetic. Mitochondria still carry signs of their ancient origin. They have their own small DNA, separate from the DNA stored in the cell nucleus. They divide in a way that resembles bacterial division, splitting from existing mitochondria rather than being built from scratch like simple cell parts. They are surrounded by membranes, including an inner membrane, with features that make sense if they descended from once independent cells. They use molecular machinery that in some ways resembles bacterial systems more than the rest of the human cell. And yet, they are no longer free-living bacteria. They cannot simply leave you and survive on their own. Over time, many of the genes they once carried were lost or moved into the nucleus of the host cell. The relationship became permanent. The old boundary between one organism and another organism blurred until a new kind of life emerged. A cell with internal power structures capable of supporting much greater complexity. Without mitochondria, the story of complex life would likely look completely different. Your muscles would not have the same endurance. Your brain, which consumes enormous energy compared with its size, could not operate in the same way. Your body's constant repair, movement, temperature regulation, signaling, and growth all depend on a steady supply of usable cellular energy. Mitochondria help produce a molecule called ATP, which cells use like an immediate energy currency. They do this through carefully controlled chemical reactions that take energy from nutrients and, with the help of oxygen, convert it into a form the cell can spend. This does not mean mitochondria are tiny batteries in a simple sense. They are dynamic organelles, changing shape, moving through cells, joining together, splitting apart, responding to stress, and helping decide how energy should be handled. In muscle cells, they support contraction and endurance. In nerve cells, they help supply the energy needed for communication and maintenance. In cells that need more energy, there are often more mitochondria. Their number and condition can change with activity, health, age, and cellular demand. In a way, they are living reminders that your body is not powered by one central flame, but by countless microscopic furnaces distributed through your tissues. But mitochondria are involved in more than energy. They help regulate cell survival, calcium balance, heat production in certain tissues, and the controlled death of damaged cells. This last role is especially profound. Sometimes a cell becomes too damaged, too dangerous, or no longer needed, and the body must remove it cleanly. Mitochondria can help trigger this orderly self-destruction, not as violence, but as maintenance of the whole. The same ancient structures that help power life also help decide when a single cell should end for the body to remain healthy. That is not a contradiction. It is one of biology's recurring truths. Life depends on balance, and sometimes survival at one level requires sacrifice at another. There is also something deeply personal about mitochondria, because in humans, most mitochondrial DNA is inherited from the mother through the egg cell. The sperm contributes nuclear DNA, but the egg carries the vast majority of the cytoplasm and mitochondria that begin the new organism's early life. This means your mitochondria connect you to a maternal line stretching backward through generations, not as a complete story of ancestry, but as a special thread of cellular inheritance. Inside you are tiny genetic echoes passed through mothers, grandmothers, and countless ancestors before them, reaching back through human history, mammal history, and eventually deep into the ancient microbial world. You are not only related to other humans, you are related to ancient life forms whose partnership made your kind of body possible. And that should make the idea of individuality feel a little wider, a little stranger. You think of yourself as one being, one person, one continuous I, but at the cellular level, you are the result of ancient mergers, borrowed tools, inherited systems, and old alliances so successful that they became invisible. The mitochondria inside you are not guests in the ordinary sense, because they are now part of your cells. But they are also not merely objects. They are descendants of a once separate form of life that became inseparable from the lineage that led to you. This is why biology often feels more mysterious when it becomes more accurate. The truth is not that life is pure, separate, and neatly divided. The truth is that life is entangled with its own history. It absorbs, adapts, merges, negotiates, and carries old relationships forward in new forms. A human cell is not a simple unit. It is a tiny world built from evolutionary memory. The nucleus holds one archive, the mitochondria hold another. Together they keep the cell alive, not as rivals, but as partners in an arrangement older than every civilization, every language, every dream humans have ever had. Of course, this ancient partnership is also fragile. When mitochondria do not work properly, cells with high energy needs can suffer. Mitochondrial disorders can affect muscles, nerves, organs, and development, sometimes severely. Aging is also associated with changes in mitochondrial function, though aging is complex and cannot be reduced to mitochondria alone. Exercise, nutrition, sleep, and overall health can influence mitochondrial activity, but there is no magical shortcut that makes them perfect. They are biological systems, not wellness slogans. They can be supported, stressed, damaged, repaired, copied, and removed when necessary. Cells even have ways to clear damaged mitochondria, a kind of internal quality control that helps maintain energy balance. Again, the body survives not by keeping every part forever, but by maintaining the pattern well enough to continue. And perhaps this is the quiet lesson mitochondria offer. You are alive because ancient life learned not only to compete, but to cooperate. Somewhere in deep time, a boundary softened. One cell entered another, or was engulfed by it, and instead of the story ending there, a new story began. From that union came cells capable of greater energy, greater size, greater complexity, and eventually the long road toward bodies that could move, sense, think, love, grieve, and ask where they came from. Every time you lift your hand, every time your eyes follow a line of text, every time your mind wanders into memory, mitochondria are helping supply the energy that makes that moment possible. They do not know you. They do not know the story they carry. But their existence means that your life is built on an ancient agreement written into the structure of the cell. So when you imagine yourself, do not picture only skin, bones, blood, and thought. Picture tiny descendants of bacteria-like ancestors, glowing with chemical purpose in the darkness of your cells, turning breath and food into usable energy, carrying a small archive from a time before animals, and reminding you that being human is not a clean break from the ancient world. It is the ancient world continuing in a new shape. Your muscles are controlled by tiny electrical signals. The smallest spark inside your body can become a lifted hand, a step forward, a blink, a breath, or the quiet tightening of your jaw when you are trying not to say what you feel. Your muscles may look like the most physical part of you, the obvious machinery of movement, the red tissue that pulls bones, shapes posture, carries weight, and gives the body its visible strength. But muscle does not move by strength alone. It moves because tiny electrical signals tell it when to contract. Without those signals, even the strongest muscle would remain silent. It would have all the protein fibers, all the structure, all the potential force, but no instruction to begin. Every voluntary motion starts as a decision or pattern in the nervous system, then travels through specialized nerve cells called motor neurons, which extend from the spinal cord toward the muscles they control. When the signal reaches the end of a motor neuron, it does not simply jump into the muscle like a bolt of lightning from the sky. It arrives at a carefully organized meeting place called the neuromuscular junction, where nerve and muscle come very close, but do not fully merge. There, the nerve releases a chemical messenger called acetylcholine, and that messenger crosses the tiny gap to receptors on the muscle fiber. When enough receptors are activated, the muscle fiber's electrical state changes, and a wave of activity spreads across the muscle cell's surface and deep into its inner structures. This wave is the beginning of contraction. It triggers the release of calcium inside the muscle fiber, and calcium allows the muscle's microscopic machinery to engage. Proteins inside the muscle, mainly actin and myosin, begin pulling past one another in a coordinated way. The muscle fiber shortens, force is produced. A finger bends, an eyelid closes, a foot presses against the ground, a smile appears, or a word is shaped in the throat. What feels like one smooth action is actually the result of countless tiny events, each one brief, precise, and dependent on the signal arriving at the right place at the right time. This is why movement is not just about muscle, it is about communication between nerve and muscle. Your body is full of motor units, each made of one motor neuron and the group of muscle fibers it controls. Some motor units are small and delicate, giving you fine control, like those used in the fingers, eyes, or voice. Others are larger and built for power, activating many fibers at once in muscles used for standing, jumping, lifting, or pushing. When you make a gentle movement, your nervous system can recruit fewer motor units. When you need more force, it can recruit more of them and increase how frequently they fire. Strength is not only the size of muscle, it is also the brain and spinal cord learning how to activate muscle more effectively. This is why early strength gains from training can happen before large visible muscle growth. The nervous system becomes better at coordination, timing, and recruitment. It learns which fibers to call, how quickly to call them, and how to reduce unnecessary tension from muscles that would get in the way. Movement is therefore not a simple command like move arm. It is a negotiation among many muscles, some contracting, some relaxing, some stabilizing, some adjusting quietly in the background. To reach for a glass, your shoulder, arm, wrist, fingers, back, neck, and even core muscles may participate. Your body must not only move the hand forward, it must keep the rest of you balanced enough for the hand to arrive accurately. The electrical signals that control muscles do not always begin in conscious choice. Some movements happen reflexively, faster than deliberate thought. If you touch something painfully hot, withdrawal can begin through spinal circuits before you fully process the situation. This is not because the brain is absent, but because survival sometimes requires speed. The spinal cord can organize certain responses quickly, while the brain receives and interprets what happened. Other muscle activity is automatic in a different way. You do not consciously plan every adjustment that keeps you upright while standing. Small muscles are constantly making corrections as your body sways slightly. Your breathing muscles work through rhythms controlled by brainstem circuits, though you can also influence breathing voluntarily for a time. Even facial expressions may begin before you have fully named the emotion. Muscles live at the border between intention and instinct. They obey conscious commands, but they also reveal what consciousness tries to hide. A tense shoulder, a clenched fist, a restless foot, a shallow breath, a softened gaze. All of these are movements or muscle states shaped by nervous system activity, sometimes before words arrive. And because muscle signals are electrical, doctors can measure some of this activity using tools like electromyography, which detects electrical patterns in muscles. These patterns can reveal whether a muscle is receiving proper nerve signals, whether a nerve is damaged, whether muscle disease is present, or how the muscle behaves during movement. The body's invisible instructions can become visible as traces on a screen, yet the signals themselves are not large dramatic shocks. They are tiny changes in voltage across cell membranes, created by charged particles moving through channels. A muscle cell is not a dead string being pulled from outside. It is an excitable living structure, ready to respond when its electrical balance shifts. After contraction, calcium must be pumped back into storage, the proteins disengage, and the muscle relaxes. This reset is just as important as the contraction. If muscles only tightened and never released, movement would become impossible. Relaxation is not laziness. It is part of control. Every graceful motion depends on the timing of both activation and release. When you walk, muscles fire in rhythmic sequences. When your foot lands, some muscles absorb impact. Others push you forward. Others stabilize the knee and hip. Others adjust the ankle. You may experience walking as automatic, but beneath it is a symphony of signals, repeating and adapting to slope, speed, surface, fatigue, and intention. If the ground is uneven, the pattern changes. If you carry a heavy bag, the pattern changes. If you are tired, injured, frightened, or excited, the pattern changes. Your muscles are not simply following a fixed program. They are responding to continuous feedback. Sensors in muscles and tendons tell the nervous system about stretch, tension, and position. This feedback helps the body know where its parts are without looking. Close your eyes and touch your nose. You can do it because the body has an inner sense of position, guided partly by receptors in muscles and joints. This means muscle control is not only output from the nervous system, it is a loop. The nervous system sends signals to muscles. Muscles move, sensors report back, and the nervous system adjusts. Action and information flow together. Fatigue also reveals how complex this system is. When a muscle tires, it is not always because the muscle has simply run out in one simple way. Fatigue can involve changes in energy supply, buildup of metabolic byproducts, reduced calcium handling, altered nerve signaling, changes in the brain's willingness to keep pushing, and protective mechanisms that limit effort before severe damage occurs. The burning in a hard-working muscle is not just weakness, it is information. The body is telling you that the conditions inside the tissue are changing. Training can improve how muscles use energy, how blood vessels supply them, how the nervous system coordinates them, and how the mind tolerates effort. This is why movement changes the body at many levels at once. A repeated exercise is not only a challenge to muscle fibers, it is a lesson to nerves, blood flow, metabolism, balance, and attention. Over time, muscles can grow stronger when the body repairs and adapts to stress, but the electrical command remains essential. A larger muscle without proper nerve connection cannot serve its purpose. In cases where nerves are injured, Muscles can weaken or shrink because they no longer receive normal activation. The relationship between nerve and muscle is so important that the muscle's health depends partly on being spoken to. Use is a kind of language. Signals keep tissue engaged. Movement tells the body that this pathway matters. Stillness, when prolonged beyond what the body can tolerate, can let strength fade. But this should not be heard as pressure to always push. Rest is also part of muscle life. Muscles need recovery, nutrients, oxygen, and time to repair after effort. The goal is not endless tension. The goal is rhythm, signal, contraction, work, release, repair, readiness. Perhaps that is why muscles offer such a powerful metaphor without needing to leave science behind. They show that strength is not constant hardness. Real strength is responsive. It knows when to contract and when to let go. It knows how to coordinate with the whole body. It knows that a single signal is small, but millions of well-timed signals can lift, run, build, speak, protect, embrace, and create. You may think of movement as something you decide and then do, but between decision and motion lies a hidden electrical story. A thought becomes a nerve impulse. A nerve impulse becomes chemical release. A chemical message becomes muscle activation. Calcium moves. Proteins slide. Force appears. The body changes position in the world, and because it happens so quickly, you call it simple. You say, I reached, I walked, I held on, as if the action belonged only to will. But beneath that will, tiny signals carry the command into flesh. Your balance depends on fluid in your inner ear. The reason you can stand still on a spinning planet without feeling like you are falling is partly because of a few tiny chambers of fluid hidden deep inside your skull. You do not see them, you do not feel them moving most of the time, and you may go through years of life without thinking about them once, but every time you walk across a room, turn your head, climb stairs, lean down to pick something up, ride in a car, spin too quickly, or close your eyes in the dark and still know which way your body is facing, your inner ear is quietly helping you stay oriented. Balance feels simple when it works. The floor seems stable, the horizon stays where it belongs. Your body knows how to correct itself before you collapse. But this stability is not something the world gives you directly. It is something your nervous system constructs from several streams of information. Your eyes telling you what the world looks like, your muscles and joints telling you where your body parts are, and your inner ear telling you how your head is moving through space. Hidden inside the temporal bone, close to the organs of hearing, is the vestibular system, a delicate set of structures that acts like an internal motion sensor. It does not use sight. It does not need sound. It depends on fluid, tiny hair-like sensory cells, and the physics of motion. 3 loop-shaped structures called semicircular canals sit at different angles, roughly arranged to detect rotations of the head in different directions. Inside them is a fluid called endolymph. When you turn your head, the bony canal moves with you, but the fluid lags behind for a moment because of inertia, the same tendency that makes water slosh in a glass when the glass moves. That slight movement of fluid bends tiny sensory hair cells inside the canal. Those hair cells do not hear in the usual sense. They detect bending. When they bend one way, they change their signal to the brain. When they bend another way, the signal changes differently. From these subtle shifts, your brain learns that your head is rotating, left or right, up or down, tilting, turning, nodding, spinning. Near the canals are 2 other structures, the utricle and saccule, which help detect straight-line acceleration and the pull of gravity. They contain tiny crystals made of calcium carbonate, often called otoliths, resting over sensory hair cells. When you tilt your head, or accelerate forward, backward, upward, or downward, these crystals shift slightly because of gravity and movement, bending the hair cells beneath them. This gives the brain information about orientation, which way is up, whether your head is tilted, whether your body is speeding up or slowing down. It is an elegant system because it turns the simplest facts of matter, fluid lagging, crystals shifting, hairs bending, into the feeling of balance. And yet, you usually notice this system only when it fails, because when balance is working, it disappears into trust. You do not consciously calculate the angle of your head each time you stand. You do not command your eyes to stabilize the world every time you turn. The inner ear communicates with brain regions that control eye movements, posture, and spatial awareness, helping keep your gaze steady even while your head moves. This reflex is one reason you can look at a sign while walking and still read it, or keep your eyes on someone's face while turning your head slightly. Without this stabilizing system, the world might seem to bounce or smear with every step. Balance is not stillness. It is correction happening so quickly that you mistake it for stillness. That is the quiet miracle. Standing upright is not the absence of motion. Your body is always swaying a little, always making tiny adjustments, always using hidden information to keep falling from becoming collapse. When the signals from the inner ear become confused, the result can be deeply unsettling. After spinning, the fluid in the semicircular canals may keep moving briefly, even after you stop, sending the brain a message that you are still rotating. Your eyes may drift and jerk as the brain tries to match a motion that is no longer happening. The room seems to move. Your body feels betrayed by space itself. In some conditions, tiny crystals from the otolith organs can become displaced and enter a semicircular canal, where they disturb the fluid movement and create sudden episodes of vertigo when the head changes position. This condition is called benign paroxysmal positional vertigo, and although it is often treatable, the experience can be frightening because the brain receives a false message of motion. You may be lying still, yet the world seems to spin. This shows something profound. Your sense of reality depends on agreement between systems. If your eyes say the room is still, but your inner ear says you are turning, the brain must resolve a conflict. Sometimes that conflict becomes dizziness, nausea, or disorientation. Motion sickness works through a similar kind of mismatch. In a car, boat, or virtual reality headset, the eyes and inner ear may send signals that do not fully agree. Your visual world may suggest movement while your body feels still, or your inner ear may sense motion while your eyes are fixed on a stable cabin. The brain reads the contradiction as something wrong, and the body can respond with discomfort. This is not weakness. It is the cost of having a brain that tries to build one coherent world from multiple sources. Balance is not a single sense in the way we usually think of seeing or hearing. It is a hidden agreement, a negotiation between body and environment. And because it is so deeply tied to survival, it affects emotion too. When balance is disturbed, people can feel panic, vulnerability, or unreality, because the ground itself no longer feels reliable. A stable world is one of the quiet foundations of calm. You trust your thoughts partly because you trust the floor. You trust the horizon. You trust that when you turn your head, the world will not slide away. The inner ear helps create that trust. It is a small organ system with enormous psychological weight. It tells your brain, moment by moment, that you are here, upright, moving this way, tilted that way, safe enough to continue. And perhaps the most beautiful thing about it is how physical the whole mystery is. Balance is not an abstract idea floating in the mind. It is fluid moving inside canals thinner than your awareness. It is crystals shifting under gravity. It is hair cells bending like reeds in a current. It is the brain translating tiny mechanical changes into the feeling that the world is steady. So the next time you walk without thinking, turn your head without falling, close your eyes and still know which way you are leaning, remember the hidden water inside your skull. Remember that your body carries its own little ocean, not for dreaming, but for orientation. Inside that quiet fluid, motion leaves a trace. Gravity writes its direction. The brain listens, and from those small signals, you are given one of life's most ordinary miracles, the ability to stand in a moving universe and feel for a while balanced. Your tongue detects more than basic taste categories. Your tongue is not a simple flavor switchboard. It is a living sensor that turns chemistry, texture, temperature, danger, memory, and desire into the intimate experience of eating. You may have been taught, directly or indirectly, that taste is made of a few neat categories, as if sweetness lives on one part of the tongue, bitterness on another, sourness somewhere else, and the mouth works like a labeled map. But that familiar tongue map is misleading. Taste receptors for different qualities are spread across the tongue, and although some areas can be more sensitive than others, the tongue does not divide flavor into strict territories like countries on a classroom poster. In reality, taste is a distributed, layered system. It begins with small structures called taste buds, many of them housed in visible bumps on the tongue called papillae, though taste buds can also be found in other parts of the mouth and throat. Inside these taste buds are specialized cells that respond to chemicals dissolved in saliva. That detail matters because your tongue does not taste dry objects directly. Food must release molecules into moisture before the cells can detect them. A crystal of salt, a drop of lemon juice, a piece of chocolate, a slice of tomato, a bitter medicine, a warm broth. All of them become meaningful only when their chemical traces meet the wet surface of the mouth. Traditionally, we speak of 5 major taste qualities: sweet, salty, sour, bitter, and umami. Sweetness often signals energy-rich carbohydrates, though not everything sweet is nourishing. Saltiness helps the body detect minerals that are essential in the right amounts but harmful in excess. Sourness can signal acidity, sometimes linked to ripeness, fermentation, or spoilage. Bitterness is especially interesting because many toxic plant compounds taste bitter, so bitterness may act as a warning system, though bitterness is not always bad. Coffee, dark chocolate, and many greens show that the brain can learn to appreciate what the tongue first questions. Umami, often described as savory or brothy, is linked to amino acids, such as glutamate, and can signal protein-rich foods. But the tongue's story does not end with these 5. Scientists continue to study whether humans have distinct taste systems for fat, calcium, metallic sensations, starch breakdown, water detection, and other qualities that may not fit cleanly into the classic categories. Fat, for example, is not only texture. There is evidence that the mouth can detect fatty acids through specific mechanisms, influencing how rich or satisfying food feels. Kokumi, a term used especially in food science, is not usually described as a basic taste by itself, but as a quality that can enhance mouthfulness, depth, and continuity in foods, making flavors feel more rounded. Even the taste of metallic is complicated, involving chemistry, sensation, and sometimes reactions with saliva or oral tissues. So when you eat, your tongue is not merely asking, "Is this sweet or salty?" It is sampling a chemical landscape, searching for patterns that once mattered deeply to survival: energy, minerals, acid, protein, possible poison, decay, ripeness, richness, and safety. Yet what you call flavor is even wider than taste. It includes smell, but not only smell. It includes texture, temperature, irritation, and expectation. To avoid repeating the full story of the nose, think of it this way. The tongue begins the meal, but the whole mouth completes it. The creamy thickness of yogurt, the crisp snap of an apple, the burn of chili, the cooling feeling of mint, the fizz of carbonation, the dryness of strong tea, the slight sting of mustard, the warmth of soup, the roughness of toasted bread. These are not all taste in the strict biological sense. Many of them involve touch and a separate chemical sensing system connected to nerves such as the trigeminal nerve, which detects irritation, heat like burn, cooling, tingling, pressure, and texture. Chili peppers feel hot not because they are physically burning your tongue, but because capsaicin activates receptors that normally respond to heat and tissue danger. Mint feels cool because menthol activates cold-sensitive pathways. Carbonated drinks tingle because dissolved carbon dioxide creates chemical and mechanical sensations. This means your mouth is not just a taste detector, it is a full sensory chamber, testing food with chemistry, touch, temperature, and warning signals all at once. Your tongue also helps shape speech, move food, form a swallow, clean the mouth, and judge whether something is safe to send deeper into the body. It is muscle, sensor, tool, and gatekeeper, and it learns. A newborn may show strong responses to sweetness and bitterness, but your preferences are shaped by culture, repetition, memory, hunger, illness, family meals, childhood associations, and even the emotional atmosphere around food. Something bitter can become comforting if it belongs to morning coffee. Something sour can become refreshing if your culture teaches you to love fermented foods or citrus. Something spicy can become pleasurable because the brain learns to mix controlled pain with reward, excitement, and expectation. Taste is therefore not fixed like a machine setting. It is biology shaped by experience. Even saliva matters more than most people realize. It dissolves food molecules, begins digestion for some substances, protects oral tissues, and changes how chemicals reach taste receptors. A dry mouth can flatten flavor. Illness can dull taste. Some medications can alter it. Aging, smoking, infections, nerve damage, dental conditions, and changes in smell can all shift the world of flavor. This is why losing taste or having it distorted can be emotionally heavy. Food is not only fuel. It is comfort, identity, memory, celebration, routine, and connection. When taste changes, the world can feel less vivid, meals less meaningful, and pleasure less available. But when taste is working, it quietly gives your life texture. It turns survival into experience. It helps transform matter from the outside world into something chosen, judged, welcomed, or rejected. The tongue is also honest in a way the mind is not always prepared for. It can reject bitterness before you have a reason. It can crave salt after sweating. It can make sweetness feel urgent when the body wants energy. It can warn you when milk has soured or when something tastes wrong before you can explain why. Of course, it is not perfect. Modern foods can overwhelm ancient systems with concentrated sugar, salt, fat, and flavor design, making the brain want more than the body needs. The same senses that once helped guide survival can be pulled by abundance. That is not a moral failure. It is biology meeting a world it did not evolve to predict. And perhaps that is the deeper question your tongue asks every day. How does a body decide what to trust? Every meal is a negotiation between instinct and knowledge, pleasure and need, memory and chemistry. You taste not only with receptors but with history. You taste with the meals that raised you, the foods you were taught to love, the warnings your body has learned, the comforts you return to when life feels uncertain. So the next time something touches your tongue, pause for a moment before calling it simply sweet, salty, sour, bitter, or savory. Beneath that small sensation is a crowded conversation. Molecules dissolving, receptors responding, nerves firing, texture pressing, temperature shifting, memory opening, and the body asking whether this piece of the world can become part of you. Your tongue detects more than basic taste categories because being alive requires more than simple labels. It requires judgment, pleasure, caution, learning, and trust. In the darkness of the mouth, before food becomes energy, before it becomes blood chemistry, before it becomes part of the hidden labor of the body, it first becomes meaning on the tongue. Your sleep cleans and resets brain processes. While you are unconscious to the world, your brain may be doing some of its most careful work. Sleep can look like disappearance from the outside, closed eyes, slower breathing, stillness, the lights of awareness dimmed until morning returns. But inside the sleeping brain, stillness is not emptiness. It is a change of mode. During the day, your brain is flooded with demands. It watches, predicts, remembers, reacts, filters noise, controls movement, manages emotion, interprets language, follows danger, and builds a continuous sense of self from thousands of tiny signals. By night, if sleep is allowed to unfold, the brain begins to shift from outward attention to inward maintenance. This does not mean sleep is a magical reset button that erases every problem, and it does not mean one night can repair every wound in the mind. But sleep is one of the body's most important forms of biological housekeeping. It helps clear certain waste products, reorganize memory, recalibrate emotional responses, restore attention, regulate learning, and prepare the brain for another day of being alive. One of the most fascinating discoveries in modern neuroscience is the glymphatic system, a waste-clearing process in the brain that appears to become more active during sleep, especially deep sleep. The brain has high energy needs, and like any active tissue, it produces waste from normal cellular work. Because the brain is protected by the skull and has a special environment, it cannot clean itself in exactly the same way other tissues do. During sleep, fluid can move through spaces around brain cells, helping wash away metabolic byproducts. Scientists are still studying the details, and it would be too simple to say that sleep flushes toxins like a drain being opened. But the core idea is real and powerful. Sleep gives the brain conditions that support cleaning and maintenance. Some studies suggest that the spaces between brain cells may change during sleep in ways that help fluid flow more easily. This matters because certain waste-related proteins, such as beta amyloid, have been studied in connection with brain aging and diseases like Alzheimer's. Though the relationship is complex and not reducible to sleep alone, still, the message is clear enough to feel almost humbling. When you sleep, the brain is not off. It is being cared for by processes that waking life cannot fully replace. Sleep also helps reset the brain by changing how memories are handled. During the day, your experiences leave traces. Some are important, some are useless, some are emotional. Some are repeated so often that they deserve to become skill. Some are noise that should not take up space forever. Sleep helps sort this crowded inner archive. During non-REM sleep, especially deeper stages, the brain appears to replay and strengthen certain patterns, helping stabilize memories and learning. During REM sleep, when dreaming is often vivid, the brain may help connect emotional memories, associations, and creative links in unusual ways. This does not mean every dream is a secret message, or that sleep perfectly files your life into neat folders. The brain is not a librarian with a candle walking through shelves. It is more like a dark ocean reorganizing its currents. Some memories are strengthened, some are softened, some are integrated into older knowledge. Some emotional edges may be processed, so they do not feel exactly the same in the morning. You may have felt this yourself. A problem that seemed impossible at night becomes slightly clearer after sleep. Not because sleep solved it like a machine, but because the mind returned with different balance, different energy, and sometimes a new relationship to the same facts. Another important idea is synaptic homeostasis. While you are awake, the brain forms and strengthens many connections as it learns and responds. But a brain cannot simply strengthen everything forever. That would become inefficient, noisy, and expensive. Sleep may help downscale some connections while preserving the more meaningful ones, reducing background clutter so the brain can stay flexible. Think of it not as deleting the day, but lowering the volume on what does not need to remain loud. In this way, sleep protects learning by preventing overload. It helps the brain remain ready to notice again. Without enough sleep, attention becomes fragile. Reaction time slows. Emotional control weakens. Irritation rises more easily. The world may feel sharper, heavier, more threatening, or strangely unreal. This is not a character flaw. It is what happens when the brain is asked to keep performing without enough restoration. Sleep loss affects the systems that help you judge, remember, regulate emotion, and make decisions. Even ordinary problems can feel larger because the brain's ability to place them in perspective has been worn thin. The emotional brain can become more reactive, while the systems that help calm and interpret those emotions may not work as smoothly. That is why a tired mind can turn a small worry into a storm. The worry may be real, but exhaustion changes the weather around it. Sleep is also rhythmic. It moves through cycles, from lighter sleep into deeper sleep, and often into REM sleep, repeating several times across the night. Each stage has its own patterns and likely serves different roles. Deep sleep is especially associated with physical restoration, certain hormone patterns, immune support, and memory-related processes. REM sleep is linked with dreaming, emotion, and learning. Though the science is still unfolding, a healthy night is not just a block of unconscious time. It is a sequence. It has architecture. It is built from waves and transitions. Cutting sleep short can remove parts of that architecture, especially later REM-rich periods or deeper restorative phases depending on timing. This is why sleep quality matters as much as hours. A person can lie in bed for a long time and still wake unrefreshed if sleep is fragmented, disrupted, or affected by stress, breathing problems, pain, light, noise, alcohol, irregular schedules, or anxiety. The brain needs not only darkness and time, but a certain kind of safety. Sleep is an act of trust. To sleep, the body must stop scanning the world with the same intensity. It must let the muscles soften, let awareness dim, let the self loosen its grip. This is why stress can make sleep so difficult. A brain that believes danger is near does not easily enter deep restoration. It keeps watch, it listens for threat, it rehearses tomorrow, it reopens old conversations. It protects you so hard that it prevents the repair you need. And perhaps this is the most human part of sleep. It is biological, but also emotional. You cannot always force it by command. You invite it through rhythm, darkness, quiet, routine, and a body that gradually learns it is safe enough to let go. The tragedy of modern life is that sleep is often treated like wasted time, something to sacrifice for productivity, entertainment, worry, or one more hour of light from a screen. But the brain does not experience sleep as waste. It experiences sleep as maintenance. Without it, the mind becomes cluttered with unfinished processing, chemical imbalance, emotional sharpness, and attention worn thin. With it, not everything becomes perfect, but something essential is given a chance to return. Clarity, patience, memory, regulation, and the quiet readiness to begin again. So the next time you fall asleep, try not to imagine yourself simply vanishing. Imagine the brain closing its doors to the outside world so it can tend to the inner one. Imagine fluid moving through hidden spaces, memories being weighed and woven, emotional signals losing some of their sharp edges, unnecessary noise being softened, and the mind preparing itself for morning. Sleep is not the opposite of life. It is one of the ways life protects itself. In the dark, while you are gone from your own awareness, the brain keeps working on your behalf, cleaning, sorting, balancing, and gently returning you to yourself. Your pupils reveal attention and emotion. Your pupils are tiny dark openings, but they can betray the hidden weather of your mind before your face knows what to show. When you look into someone's eyes, you may think you are seeing color, expression, softness, fear, attraction, fatigue, or attention. But at the center of each eye is a small black circle quietly adjusting to more than light. The pupil is not a structure by itself in the way a lens or muscle is. It is an opening in the iris, the colored ring around it, and the iris controls how wide that opening becomes. In bright light, the pupil usually constricts to reduce how much light enters, protecting the retina and sharpening vision. In darkness, it widens to allow more light in, giving the eye a better chance to see. This part seems simple, like a camera adjusting its aperture, but the human pupil is not only a light control mechanism, it is also influenced by the autonomic nervous system, the part of the body that quietly adjusts functions like heart rate, digestion, sweating, and internal readiness without needing your conscious permission. When the sympathetic branch becomes more active, often linked with arousal, alertness, challenge, or emotional intensity, the pupils can dilate. When the parasympathetic branch is more dominant, the pupils can constrict through a different pathway. This does not mean you can look into someone's eyes and read their soul like a book. Pupil size is affected by many things: light, distance, medications, drugs, fatigue, eye health, neurological conditions, age, and even where someone is focusing. But it does mean the pupil is not emotionally silent. It can change when the brain is working harder, when attention sharpens, when something becomes important, when fear rises, when desire appears, when surprise interrupts expectation, or when the body quietly prepares to respond. In research, scientists use pupillometry, the measurement of pupil changes, to study attention, mental effort, emotional arousal, and decision-making, because pupil size can reflect changes in brain and body state. If a task becomes more demanding, the pupils may widen slightly, as if the eyes are not only letting in light, but also revealing that the mind is spending more energy. When you concentrate on a difficult problem, follow a tense scene, hear your name in a noisy room, or notice something emotionally charged, your pupils may respond before you could explain why. They are not telling a complete story, but they are giving a tiny physiological clue that something inside the system has shifted. This is why the eyes can feel so alive in conversation. It is not only because they move or shine or hold attention, it is because they are linked to the body's deeper state of readiness. A sudden widening of the pupils can accompany interest or alarm. A narrowing may occur with bright light or certain forms of focus. Even the act of looking at something near causes the pupils to constrict as part of a coordinated response that also changes lens shape and eye position, helping you see close objects clearly. So the pupil is constantly caught between the outside world and the inside world. Light pulls on it, distance pulls on it, emotion pulls on it, attention pulls on it, the body's chemistry pulls on it, and all of these influences meet in one small circle of darkness. Clinicians also pay close attention to pupils because they can reveal important information about the nervous system. When a doctor shines a light into your eye, they are not simply checking whether you can see brightness. They are testing a reflex pathway that involves the retina, optic nerve, brain regions, and nerves that control the iris. Pupils that are unequal, unusually fixed, or respond poorly to light can sometimes suggest injury, drug effects, nerve problems, or serious changes in brain function. In emergency medicine, the pupil can become a small visible window into hidden neurological danger. That does not mean every difference in pupil size is an emergency. Many people have slight natural differences and context matters. But it shows how much information the body can place in something so small. Your pupils also reveal the limits of control. You can choose to smile. You can choose to speak calmly. You can choose to look away. But you cannot easily command your pupils to widen with sincerity or shrink with confidence. They answer to systems older and deeper than performance. This is part of why eye contact can feel intimate or uncomfortable. When someone looks at you closely, it can feel as if they are near a doorway you cannot fully close. The eyes do not expose everything, but they expose enough to remind you that the body is always participating in emotion. A person can say, "I'm fine," while their breath, posture, skin, voice, and pupils may hint at another story. And yet, we must be careful not to turn this into a false science of mind reading. A dilated pupil does not always mean attraction. A small pupil does not always mean coldness. The body is more complex than one signal. Light in the room may have changed. A medication may be involved. The person may be tired, stressed, focused, or simply looking at something farther away. The honest lesson is not that pupils reveal one exact emotion, but that attention and emotion are physical. They do not float invisibly above the body. They move through nerves, muscles, blood flow, chemistry, and reflexes. Your inner life leaves small traces in matter. The pupil is one of those traces. It is a black circle that changes shape because your nervous system is continuously adjusting how much of the world to receive and how ready the body should be to act. Perhaps that is what makes the pupil so fascinating. It is darkness that responds. It has no color of its own, yet it shapes how color reaches you. It is empty space, yet it tells a story of attention. It is not a window in the poetic sense only, but a living aperture between the outer world and the inner state. When something matters, your body may open the gate a little wider. When brightness overwhelms, it narrows the opening to protect you. When danger appears, when effort rises, when curiosity sharpens, when emotion passes through like weather across a hidden field, the pupil may quietly shift. So the next time you meet someone's gaze, or catch your own eyes in the mirror, remember that those dark centers are not still. They are moving with the light, with the nervous system, with the silent effort of being awake. They are small, but they belong to a vast conversation between brain, body, and world. And in that tiny changing circle, you can see a deeper truth about being human. Even the parts of you that seem silent are speaking, not in words, but in signals. Your hormones quietly shape behavior. Some of your choices begin as whispers in the blood before they ever become thoughts in your mind. You may experience behavior as something you decide from the clean center of yourself, as if there is a small captain behind your eyes choosing when to speak, when to rest, when to reach for food, when to trust someone, when to feel alert, when to withdraw, when to become patient, when to lose patience. But the body is not governed by thought alone. Beneath your awareness, hormones are constantly shaping the background conditions from which thought and behavior rise. They do not control you like a puppet. They do not erase responsibility, personality, memory, or choice. But they influence the tone of the body, the urgency of needs, the strength of drives, the sharpness of stress, the softness of bonding, the timing of hunger, the rhythm of sleep, the pull of desire, the capacity for focus, and even the way certain situations feel before you have explained them. Hormones are chemical messengers released by glands and tissues into the bloodstream, traveling through the body to reach cells that have the right receptors to respond. A hormone can move quietly, invisibly, and slowly compared with a nerve signal, but its effects can spread widely, like a change in weather moving across a landscape. The nervous system can react in fractions of a second, but hormones often create longer-lasting states. They can prepare you for danger, help you recover after danger, regulate energy, influence growth, guide reproductive cycles, support metabolism, shape sleep timing, and help coordinate the body as one connected organism rather than a crowd of separate parts. Think of cortisol, often called the stress hormone, though that name is too simple. Cortisol helps the body respond to challenges by influencing blood sugar, inflammation, alertness, and energy availability. In the morning, cortisol normally rises as part of the body's daily rhythm, helping you wake and meet the day. During stress, it can help mobilize resources so you can cope. But when stress becomes chronic, when the body keeps receiving the message that life is unsafe or demanding without relief, this same system can become exhausting. The issue is not that cortisol is bad. The issue is timing, amount, and context. A hormone that helps you survive a short emergency can become a burden when the emergency never seems to end. Adrenaline is similar in its misunderstood power. It can make the heart beat faster, widen airways, sharpen readiness, and redirect energy toward action. It is part of why fear can make the body feel suddenly electric, but it can also surge during excitement, competition, anticipation, or emotional intensity. The body does not always divide feelings into neat categories the way language does. Fear and excitement can share physical ingredients, and sometimes what you call anxiety or courage depends partly on the story your mind attaches to the same bodily storm. Then, there are hormones involved in hunger and fullness, such as ghrelin and leptin, which help tell the brain about energy need and storage. Hunger is not simply lack of willpower or a thought about food. It is a biological state, shaped by signals from the stomach, fat tissue, blood sugar, habits, sleep, stress, and environment. If sleep is poor, appetite signals can shift. If stress is high, cravings can change. If the body has been underfed, it may push behavior towards seeking energy. The mind may call it desire, but the body may be speaking in chemistry. Insulin helps manage blood sugar after meals, guiding energy into cells and storage pathways. Thyroid hormones influence metabolic rate, temperature, and energy use, which is why too much or too little thyroid activity can affect mood, weight, heart rate, and the felt speed of the body. Sex hormones such as estrogen, progesterone, and testosterone also shape more than reproduction. They can influence bone health, muscle, skin, energy, libido, mood, and brain function, though their effects vary greatly between individuals and across life stages. Oxytocin is often called the bonding hormone, but even that label is incomplete. It is involved in childbirth, breastfeeding, social bonding, and aspects of trust and attachment. Yet it does not simply create love in a pure and universal way. Hormones rarely have one meaning. Their effects depend on the body they enter, the receptors present, the situation, the person's history, and the wider network of other signals. That is why simple statements like, "This hormone makes you happy," or "That hormone makes you aggressive," are usually misleading. Biology is not a row of buttons. It is a system of relationships. A chemical messenger can do different things in different tissues. It can support one behavior in one context and another in a different context. It can amplify a tendency that memory and environment have already prepared. It can make a feeling more likely without making it inevitable. This distinction matters because hormones are often used to explain people too crudely, as if a person's behavior can be reduced to one molecule. The truth is deeper and more respectful. Hormones shape the conditions in which behavior becomes easier or harder, stronger or softer, more urgent or more distant. They are part of the stage lighting of the self. They do not write the entire play, but they change how every scene feels. You know this in ordinary life. When you are exhausted, the same problem feels larger. When you are hungry, patience can thin. When you are calm and rested, a difficult conversation may become possible. When your body is flooded with stress, a harmless comment can feel like an attack. When you feel safe and connected, your voice may soften before you notice it. These are not excuses for every action, but they are reminders that behavior is embodied. The self is not a floating decision maker untouched by biology. The self is built inside a body that is always signaling, adjusting, preparing, and remembering. Hormones also move through time. They rise and fall in daily rhythms, monthly rhythms, developmental stages, pregnancy, postpartum periods, puberty, aging, illness, and recovery. Puberty, for example, is not only physical change, it is a remodeling of drives, emotions, social awareness, and identity under the influence of hormonal shifts and brain development. Menopause and andropause-related changes can alter energy, sleep, mood, and body composition in different ways. Pregnancy involves enormous hormonal changes that help support the developing baby and prepare the body for birth and caregiving, while the postpartum period can bring dramatic shifts that affect emotion and physical recovery. These changes are not merely moods, they are whole-body transitions. And because hormones communicate with the brain, the immune system, metabolism, and organs, their influence can be subtle but far-reaching. This is why endocrine disorders, such as diabetes, thyroid disease, adrenal problems, or reproductive hormone imbalances, can affect not only lab numbers, but the way a person feels and behaves. A body out of hormonal balance may experience fatigue, irritability, brain fog, appetite changes, sleep disruption, anxiety-like sensations, or low motivation. Again, this does not mean every feeling is hormonal. Human life is too layered for that, but it means the chemical environment of the body helps shape the emotional and behavioral landscape. Perhaps the most important lesson is compassion. If hormones can influence behavior, then people are not always struggling because they are weak, lazy, dramatic, or irrational. Sometimes the body is pushing from below awareness. Sometimes the blood is carrying messages the mind has not yet translated. Sometimes a person's reaction is partly a nervous system and endocrine system trying to protect, conserve, seek, attach, escape, or recover. This does not remove accountability. It adds understanding. It asks you to see behavior not as pure choice or pure chemistry, but as a meeting point between biology and meaning. You are not controlled by hormones, but you are never outside them. They help set the tempo of hunger, energy, fear, bonding, rest, desire, growth, and response. They are the quiet weather behind the visible act. So the next time you wonder why you feel restless, tender, driven, tired, hungry, guarded, or unexpectedly calm, remember that your body may be speaking before your thoughts arrive. In the hidden rivers of your blood, messages are traveling from gland to brain, from tissue to tissue, from need to action. And somewhere between chemistry and choice, between signal and story, your behavior takes shape, not as a simple command, but as the living negotiation of a body trying to keep you alive, connected and moving through the world. Your body is always fighting entropy. Your body is not simply alive. It is constantly resisting the universe's quiet pull toward disorder. Every second you remain warm, structured, awake, healing, balanced, and recognizable. Something inside you is pushing back against a natural tendency for things to spread out, break down, mix, cool, decay, and lose organization. This tendency is often called entropy, and although the word can sound abstract, the reality is familiar. A hot drink cools on a table. A room becomes messy if no one maintains it. Metal rusts. Food spoils. A sandcastle collapses under wind and waves. Order can exist, but it usually costs effort to preserve. Your body is one of the most astonishing examples of that effort. It is not a static object that simply has order. It is a living process that must keep rebuilding order moment by moment, using energy from food, oxygen from breath, water, minerals, and countless molecular systems to hold itself together against the slow drift toward breakdown. The proteins in your cells must be folded into useful shapes. Membranes must keep certain substances in and others out. Salt levels must be controlled. Acidity must be balanced. DNA must be repaired when damaged. Waste must be removed. Damaged parts must be recycled. Temperature must be defended. Blood chemistry must stay within limits. Cells must know when to grow, when to stop, when to repair, and when to step aside. None of this happens because the body is exempt from physics. It happens because the body uses physics carefully. Life does not defeat entropy in the whole universe. That would be impossible. Instead, life creates local order by spending energy and releasing disorder elsewhere, mostly as heat and waste. When you eat, your body is not just filling a container. It is taking ordered chemical energy from food and converting it into motion, repair, warmth, thinking, digestion, immune defense, and cellular work. But every conversion is imperfect. Heat is released. Molecules are broken down. Waste products are made. The body maintains its inner structure by participating in a larger flow of energy. In that sense, you are not a closed machine. You are an open system, constantly exchanging matter and energy with the world. You breathe in oxygen and breathe out carbon dioxide. You take in food and release heat. You drink water and lose water. You absorb sunlight indirectly through the food chain, because plants once captured sunlight and turned it into chemical forms other organisms could use. Your body's order is borrowed from the world and paid back through transformation. This is why life must keep moving internally even when you are still. If the flow stops, order begins to fail. Cells depend on tiny differences across their membranes, differences in charged particles, nutrients, and chemicals. These differences are like stored tension, like water behind a dam, and they allow cells to signal, transport, and survive. But natural processes tend to erase differences. Concentrations spread out. Heat disperses. Structures degrade. So cells spend energy to maintain gradients, repair molecules, replace worn parts, and keep their internal environment separate from the chaos outside. Your body is full of small boundaries doing heroic work. Membranes around cells, membranes around organelles, barriers in the gut, barriers in the brain, skin around the body, compartments inside tissues. Each boundary says, in its own biological language, this belongs here, that belongs there, and the difference matters. But boundaries are never free. They must be maintained. A cell that cannot maintain its boundaries loses control of itself. A body that cannot regulate its chemistry loses the conditions for life. That is why death is not simply the absence of movement. It is the loss of organized regulation. After death, the systems that maintained order stop spending energy. The body no longer repairs damage, pumps ions, renews cells, clears waste, controls microbes, or manages chemistry. Then the ordinary rules of matter become more visible. Molecules break down, structures soften. Temperature equalizes with the environment. The body returns to the wider world. Life, then, is not a permanent escape from entropy. It is a temporary, beautiful resistance. A candle flame holding shape only because fuel keeps flowing. And even while you are alive, the struggle is constant. Your cells produce damaged proteins that must be refolded or destroyed. They experience oxidative stress from normal metabolism. They make mistakes during copying and must correct many of them. They recycle worn-out parts through systems like autophagy, where damaged cellular components can be broken down and reused. Your body is not clean because nothing goes wrong. It is clean because countless things go slightly wrong all the time and are corrected before they become collapse. This is a deeper view of health, not perfection, but maintenance, not stillness, but active repair, not a body without disorder, but a body skilled at managing disorder. Aging can be understood partly through this lens, though it is not only one process. Over time, damage accumulates, repair systems become less efficient, cells may lose function, tissues change, and the body's ability to maintain order can weaken. But aging is not simply entropy acting alone like a single villain. It involves genetics, metabolism, immune changes, cellular stress, environment, chance, and many interacting systems. Still, the broad pattern is clear. To live is to keep organization going, and to age is partly to feel how difficult that maintenance becomes across time. Yet there is nothing hopeless in this. In fact, it makes ordinary care feel more meaningful. Sleep, nourishment, movement, hydration, recovery, sunlight in healthy amounts, social calm, and medical care are not shallow lifestyle details. They are ways of supporting the body's ongoing fight to maintain order. When you rest, some repair systems can do their work better. When you eat well, you provide materials and energy. When you move, you signal tissues to stay useful and responsive. When you avoid unnecessary harm, you reduce the repair burden. You are not trying to become immortal. You are helping the body continue its daily negotiation with disorder. And perhaps this is where entropy becomes more than a science concept. It becomes a way to understand why life feels so precious. A living body is improbable, not because it violates nature, but because it organizes nature with astonishing care. The atoms inside you could be scattered, mixed into soil, air, water, dust, and stone. Instead, for a while, they are arranged into eyes that see, hands that touch, lungs that breathe, cells that repair, and a mind that can wonder about the arrangement itself. You are not a thing standing outside the universe's laws. You are those laws forming a temporary island of order. Every heartbeat, every repaired wound, every remembered face, every warm breath on a cold morning is part of that island being maintained. So the next time you feel ordinary, remember how much work ordinary requires. Inside you, disorder is always being answered. Molecules are being sorted, damage is being corrected, boundaries are being defended. Energy is being spent so that your body can remain for another moment a person instead of scattered matter. Life is not the absence of entropy. Life is the art of moving through entropy without immediately surrendering to it. And for now, in this breath, in this warmth, in this fragile structure you call yourself, the body is still holding the pattern together. Aging is not one process, but many. Aging does not arrive as one shadow. It arrives as many small changes speaking at different speeds inside the same body. You may imagine aging as a single clock, hidden somewhere in the cells, ticking steadily from birth toward decline. But the truth is more layered, more uneven, and more mysterious than that. There is no one switch called aging that simply turns the body old. Aging is not one process, but many processes overlapping. Some genetic, some cellular, some chemical, some immune, some hormonal, some mechanical, some environmental, some shaped by chance, and some shaped by the life a person has lived. This is why two people can be the same chronological age and feel so different inside their bodies. One person's blood vessels may be aging faster than their muscles. Another person's joints may feel older than their mind. Someone's skin may show time early while their heart remains strong. Someone else may look youthful while hidden metabolic changes are already developing. The calendar counts years in a straight line, but biology does not always obey the calendar. Your body is made of many tissues, and each tissue carries time differently. The lens of the eye, the immune system, the skin, the brain, the bones, the muscles, the liver, the blood vessels, and the reproductive system do not all age in the same rhythm. Aging is more like an orchestra slowly losing perfect coordination than a single instrument becoming quiet. One of the reasons this happens is that cells collect changes over time. DNA can be damaged by normal metabolism, sunlight, toxins, copying errors, and ordinary cellular stress. Most of this damage is repaired, but repair is not perfect forever. Small errors can accumulate, and even when they do not immediately cause disease, they can change how well a cell functions. Telomeres, the protective caps at the ends of chromosomes, can shorten as many cells divide, acting less like a simple death clock and more like one part of a larger system that limits how long certain cells can keep copying themselves safely. Some cells eventually enter a state called senescence, where they stop dividing but do not disappear. This can be protective at first, because it helps prevent damaged cells from multiplying. But if too many senescent cells remain, they can release inflammatory signals and disturb nearby tissue. So again, aging is not just wear and tear. It is a collection of protective systems that can become problematic when they linger too long or lose balance. Your body also depends on protein quality control. Proteins must fold into the right shapes to do their jobs, and cells have systems to refold damaged proteins or break them down when they become useless. Over time, these cleanup systems can become less efficient, allowing misfolded or damaged proteins to accumulate in certain tissues. This matters especially in long-lived cells, including parts of the nervous system where the body cannot simply replace everything quickly. Meanwhile, stem cells, the cells that help renew and repair many tissues, can lose some of their capacity with age. A young body often repairs with more speed and flexibility. An older body may still repair, but sometimes more slowly, with more scarring, less precision, or less reserve. This is why recovery from injury, illness, or stress can take longer later in life. It is not that the body forgets how to heal. It is that the systems supporting repair have changed. The immune system also ages, and this is one of the most important pieces of the puzzle. With time, immune defenses may become less sharp against new threats, while also becoming more prone to low-level chronic inflammation. This quiet background inflammation is sometimes called inflammaging, and it can influence tissues throughout the body. It is not the dramatic inflammation of a swollen wound. It is more like a low, persistent static in the body's communication system, affecting blood vessels, metabolism, joints, brain health, and general resilience. Hormonal patterns shift too. Sleep patterns often change. Muscle mass may decline if the body is not challenged and nourished well. Bones may lose density. Blood vessels can stiffen. The connective tissues that help give skin, tendons, and organs their elasticity can change as proteins become altered and cross-linked over time. Even the energy systems inside cells can become less efficient. But this does not happen in isolation. It interacts with nutrition, movement, oxygen use, inflammation, and cellular stress responses. Aging is a web, not a ladder. Pull one thread and many others move. That is why simple explanations are usually false. Aging is not only about telomeres. It is not only about mitochondria. It is not only about genes, sugar, stress, inflammation, hormones, or lifestyle. Each of those matters, but none of them alone explains the whole human journey. And this is also why there is no single proven cure for aging. Science is learning how to measure biological age more carefully, how to understand cellular senescence, how to study epigenetic changes, how to protect metabolic health, how to extend health span, and how to help people remain stronger for longer. But honest science does not promise immortality from one pill, one supplement, one diet, or one routine. The real goal is not merely to add years, but to preserve function, clarity, mobility, independence, and quality of life for as long as possible. This idea is called health span, the period of life spent in relatively good health. Lifespan asks how long a person lives. Health span asks how much of that life remains livable. And this difference matters, because aging is not only about survival. It is about whether the body can still carry joy, movement, memory, curiosity, and connection. The beautiful part is that although aging cannot be stopped completely, many of its pathways are influenced by conditions. Regular movement can help preserve muscle, balance, blood vessel function, insulin sensitivity, and even brain health. Enough protein and nutrient-rich food can support repair and maintenance. Sleep gives the body time to regulate many systems. Social connection affects stress and resilience. Avoiding smoking, limiting excessive alcohol, protecting skin from too much ultraviolet damage, treating high blood pressure, managing diabetes, and staying mentally engaged can all shape how aging unfolds. These are not magical shields. They are ways of reducing pressure on the systems that time already challenges. Aging still comes, but it does not come identically for everyone, and it does not touch every tissue at once. Perhaps the deepest truth is that aging is not the opposite of life. Aging is life continuing under the burden of its own history. Every scar, every adaptation, every immune memory, every habit, every year of repair, every season of stress and recovery leaves some trace in the body. You are not simply getting older. You are becoming an archive of biological negotiations. Some parts of you become wiser in their response. Some become slower. Some become more fragile. Some remain surprisingly strong. And because aging is many processes, it asks for a gentler way of seeing yourself. Not as a machine failing, not as a single clock running down, but as a living landscape changing unevenly across time. The body does not age all at once. It ages in layers, in tissues, in signals, in repairs, in memories written into cells. And maybe that is what makes growing older both frightening and sacred. You are watching the same body that carried you through childhood. Hunger, illness, healing, laughter, fear, love, and sleep continue its long conversation with time. It is not one process, it is many. And somewhere inside all those changes, the self keeps asking how to remain whole while never remaining the same. Being human is a collaboration of cells, microbes, and memory. To be human is not to be a single thing, but a living agreement between countless forms of memory. You wake each morning feeling like one person, one body, one private self looking out from behind your eyes. And that feeling is useful, maybe even necessary. Because without it, life would become too scattered to hold. You need the sense of I to choose, to remember, to love, to protect yourself, to keep walking through the day as if there is one continuous being moving from yesterday into tomorrow. But beneath that smooth experience is a much stranger truth. Being human is a collaboration. Your body is built from trillions of human cells, each with its own small duties, its own boundaries, its own chemical needs, its own quiet participation in the larger pattern. Your surfaces and inner spaces are shared with microbial communities that influence digestion, immune training, and the living environment inside and around you. Your mind is shaped by memory, not only conscious memories you can describe, but also bodily memory, immune memory, emotional memory, motor memory, genetic inheritance, learned habits, and the patterns your nervous system has built from everything you've survived. You are not one voice speaking alone in an empty room. You are a choir so well coordinated that it sounds from the inside like a single note. And this is what makes the human body so astonishing. It holds together many kinds of life and many kinds of history without needing you to consciously manage most of them. A skin cell does not know your name, yet it participates in your boundary with the world. A muscle cell does not know your plans, yet it helps you reach for the future. A white blood cell does not understand your memories, yet it may carry its own biological memory of dangers once encountered. A microbe living in or on you is not you in the narrow sense, yet the environment it helps shape can become part of your health. A neuron does not contain a whole childhood, yet networks of neurons can help bring back the feeling of a room, a voice, a fear, a comfort, a loss. The self you feel so naturally is not stored in one location, like a jewel hidden in a box. It emerges from relationships, cells communicating, tissues coordinating, organs regulating, microbes interacting, memories updating, and the brain constantly weaving signals into a story stable enough to be lived. This does not make you less real. It makes you more real because reality itself is often relational. A song is not only the notes written on a page, it is the timing between them, the breath, the silence, the instrument, the listener. A forest is not only trees, it is soil, fungi, roots, animals, water, decay, sunlight, and the slow exchange of matter beneath the surface. A person is not only human cells arranged in a shape. A person is an organized living process, an ecosystem with a memory, a body that carries other lives, a mind that carries earlier versions of itself. Even your sense of identity depends on continuity built from change. The cells in your body are not all permanent. The microbes around and within you shift with diet, illness, environment, medicine, contact, and time. Your memories are not perfect recordings. They are living reconstructions, touched by emotion and reshaped by each return. And still, through all this movement, you remain recognizable to yourself. This is one of the deepest paradoxes of being human. You persist not because nothing changes, but because change is organized well enough to preserve a pattern. Your body replaces, repairs, filters, learns, forgets, defends, adapts, and negotiates. Your mind revises its own past while still calling it my life. Your microbiome changes while still belonging to your personal ecology. Your immune system learns the difference between threat and tolerance. Your nervous system learns which sounds mean danger, which faces mean safety, which habits lead toward relief, which memories should be approached carefully. Being human is therefore not a fixed possession. It is an ongoing collaboration between what was inherited, what was learned, what was hosted, what was repaired, and what was remembered. And because collaboration can be fragile, health is not merely the absence of disease. Health is coordination. It is cells responding to the right signals. It is microbial communities remaining balanced enough to coexist. It is immune defenses strong enough to protect but calm enough not to attack the self. It is memory useful enough to guide but flexible enough not to trap. It is the body knowing how to maintain boundaries while still exchanging with the world. You are open and closed at the same time. You breathe in the atmosphere, absorb food from the outside world, share space with microbes, receive sunlight, respond to touch, learn from voices, and carry emotional traces of people who may no longer be near you. Yet you also maintain a boundary. You do not dissolve into everything around you. Your skin, immune system, nervous system, and sense of self keep shaping the line between me and not me. But that line is not a wall of stone. It is a living border, constantly negotiated. Food becomes body, experience becomes memory. Microbes become companions or threats depending on context. Words from other people become beliefs inside your mind. Love changes your nervous system. Fear changes posture. Repetition changes skill. Illness changes priorities. Time changes what you think you are. This is why the idea of being a single individual is both true and incomplete. You are an individual in the sense that your experience cannot be fully lived by anyone else. No one can occupy your exact body, your exact history, your exact pattern of attention. But you are also collective in the sense that your life depends on cooperation at every scale. Cells must cooperate to make tissues. Organs must cooperate to keep chemistry stable. Microbes and human systems must coexist. Memories must cooperate with the present without overwhelming it. Even consciousness depends on countless processes that never become conscious. The eye is like a flame at the top of a candle, visible and vivid, but it exists only because wax, wick, oxygen, heat, and environment are working together beneath it. And perhaps this should make us gentler with the body. It is not merely a tool that carries the mind around. It is not an object to punish, decorate, compare, or ignore. It is a society of living processes trying to keep agreement. When you are tired, something in that society is asking for restoration. When you are hungry, something is asking for energy. When you feel uneasy without knowing why, the body may be reporting signals before language can organize them. When a memory returns with force, the past is not simply visiting, it is being reactivated through living tissue. When you heal, the body is not erasing damage. It is rebuilding relationship. And when you age, the collaboration does not suddenly end. It changes, sometimes becoming more vulnerable, sometimes more wise, sometimes more dependent on care, rhythm, and patience. The miracle is not that the system never fails. The miracle is that it works as often as it does. Trillions of cells, countless signals, hidden microbial lives, old memories, new experiences. Immune lessons, sensory impressions, repair systems, and emotional histories all gather into the ordinary sentence, I am here. So the next time you think of yourself as simply one body moving through the world, pause for a moment and widen the image. You are not a lonely machine sealed inside skin. You are a collaboration of cells, microbes, and memory, a living archive of ancient biology and personal history, a temporary harmony of many small lives and many remembered moments. You are built from cooperation so deep, you almost mistake it for solitude. And maybe that is the soft final truth of the human body. The self is not less beautiful because it is shared. It is beautiful because so much must come together, silently and continuously, for you to feel like one.